Hello. Good morning, everybody. It's time to start. Welcome back to the event for our second and last day. I would like to call on the stage our first speaker of the day, who is Antea Comellini from Thales Alenia Space, but also he's a reserve astronaut who is going to explain to us how will energy be leveraged for future life on space. Thank you, Antea.
Okay, so we have been hearing yesterday and we are going to hear today a lot of presentation and talks about what the space sector can do for the energy sector and how can we maximize the benefits for humanity on Earth. But today we are going to focus more during my presentation on what actually the energy sector can do for space and how we are going to use energy to support future space exploration, human and robotic, but especially human exploration. So what you see in this image is the ISS. I think you are all familiar with it. It's the International Space Station, which is orbiting at 400 kilometers from the Earth's surface. And it's quite big. The whole size is about the football field. And the most striking things that you see are the solar panels. So I will provide you with an overview of how we are using today energy on the most important outpost of humanity in space, which is this station in low Earth orbit. Of course, you see those are solar panels, solar arrays, wings, and therefore we are using photovoltaic energy, which is quite a challenge in space because you can also see there are some radiators close to those solar wings that are needed to dissipate all the heat that's accumulated by the photovoltaic process. So what are the different systems that we are using? You see three of them. The solar panel were actually used especially in the first mission when the big wings were not there yet. But at the moment, the biggest amount of power is provided by two systems, this SAW, these solar array wings, and the IROSA, so the ISS roll-out solar arrays. This SAW, they're actually the biggest and largest solar array ever assembled in space. Each one of them, we have 8 of them, and they are the size of 35 times 12 meters. And they can produce, each one of them can produce 31 kilowatts of power, which result in 240 kilowatts when they are in direct energy, but of course we are orbiting Earth. We are orbiting Earth at 400 kilometers, as I said, which results in a speed of 7 kilometers per second, which means that actually the ISS revolves around the Earth every 90 minutes, and it means that we are going to have an alternate of night and sun every 90 minutes, so about 35 minutes of night, and therefore the average power that is produced is around 100 kilowatts on one orbit. And we use this energy for multiple purposes to sustain the system of the ISS itself, to sustain the life of the astronaut, but also to power all the experiments that we are doing on the ISS, because ultimately this is the reason why we're going to space to do science. Those panels were actually originally sized for 15 years life service, but what usually happens in the space sector is that we design things that last a lot more of the original lifetime, so we are still using them, but of course the efficiency is going down. So we needed a sort of replacement, and these are the IROSA. So in this photo you can actually see that at the moment 6 pair of IROSA were already installed. The goal is to install 8 of them for each one of the SAW by 2025. And of course, we had a lot of progress in the energy sector, in the solar array sector. So those panels are much more efficient, which means that for the same mass, we are going to have a higher production of powers. And when we launch things in space, we want them to have quite a low mass. So this is very good for the launch. But also, they are very efficient also for another aspect. Those are flexible and rollable panels, which means that they can be rolled during launch. And this actually makes us save also a lot of volume during launch, which is another important parameter. And as I said, there is this alternance between night and day. So it's quite challenging because you have a cycle every 90 minutes. So you need batteries and batteries that sustain a lot of charging and discharging cycles. So during days, you are going to produce an exceed of power to sustain the ISS, but also to charge the batteries. And then during night, you need those batteries to sustain and keep the operation seamlessly as during sunlight, but also to sustain some types of emergencies. And this was provided originally by nickel hydrogen batteries that were designed for a 6.5 lifetime. Of course, they exceeded this lifetime, but we started replacing them in the 2017 with lithium-ion batteries. So lithium-ion batteries normally can sustain lower number of recycling cycles rather than the nickel hydrogen. But since we had a lot of progress in terms of technology, those batteries that we replace are actually more efficient and sustain more charging and discharging cycle than the original batteries. So actually, the one that we send in space are designed for a lifetime of 10 years. The image that you see here with the Earth on the background is actually the robotic arm of the ISS, which is discharging into space a pallet of batteries, the old batteries that were going to make the orbit and burn into the atmosphere. At the moment, this is the best that we can do when we want to free space from the things that we have sent in orbit, because we have a huge problem with the overpopulation of space, especially lower orbit and space debris. So we deorbit things into the atmosphere, and if they can burn completely, we do an uncontrolled re-entry. If there are some big parts or the satellite is pretty massive, we must do a control re-entry. There, we are trying to assess what is the impact in terms of environment and atmosphere when we are making things re-enter. This can be a problem, especially for aluminium, but the studies are already preliminary, and for the moment, this is the best thing that we can do. But what happened when the environmental conditions change? So I told you about the fact that we have this cycle between light and night, and it goes around every 90 minutes. But this is pretty a favorable condition. But when we are going to explore lunar surface, Mars surface, this condition is not going to be there anymore. For lunar surface, we are going to aim for zones in which there is ice, and those zones are at the poles, and there the night can last until 14 days. When we are going to explore Mars, okay, there we have an alternance between day and night, which is pretty similar to Earth. We are at a distance which is quite good in terms of with respect to the sun, so we are still receiving enough power to rely on the solar panel and batteries. But the problem in Mars is that we have an atmosphere, and this atmosphere, if we see that we also have sun, it means that we can have sunstorms. And those sunstorms you see in the photo, they can last a long time, and they can make solar array almost unusable. So we need other type of energy sources. And also the type of exploration that we want to do on lunar surface, on Mars surface, is going to be pretty different from what, for example, the Apollo mission gave us, which was basically a touchdown. We fetch a stone and we go back. We want to demonstrate that we are capable to sustain the life of astronauts in a sustainable way and for a long time on the lunar surface for a start and then on Mars. And this would be to explore, to do science, to also demonstrate technology that can allow us to sustain life in those environments, to build up a circular economy, and also to exploit the resources that we find in situ, and maybe also to bring back those resources. So we are going to need a lot of powers, and this cannot be provided by chemical storage means, so batteries with solar panel, or at least we can use also this type of source, but then we will need something more reliable, something with a bigger density energy, because we also have to consider that those destinations are far away. So it's already a lot to send things in lower orbit. It's another thing to send them to the moon surface, to Mars. And the solution at the moment for the space agency would be nuclear power systems. So nuclear power systems, as I said, they have a very high density, energy density and scalability. There are different types of things that we can do with nuclear power system. The first are RPS, so radioisotope power systems, for heating and electricity. Basically, we use radioactive, the decay of radioactive material for thermal and electric power production. And this is something that has been done since the 60s. All the probes that were sent very far away in our solar system, they were going to be so far from the sun that the energy reaching the solar array was not enough to power them, so they were equipped with this type of equipment. You see this is used in the Mars rover, Perseverance. This was used also in the ESA NASA mission Cassini-Huygens, which was a mission to Saturn with the lander, which was built in Europe and was relying on RPS. And in the future, what we are going to need are fission power system. So nuclear reactor, either small or big, on lunar surface, Mars surface, and this is what is going to be capable to sustain the habitat of the astronaut, but also to sustain their activities, which are going to be quite power hungry. And finally, another type of energy that we need, of course, is energy to propel the spacecraft. And therefore, nuclear thermal propulsion can be a solution because it has a very high specific impulse, and this parameter is the one you are looking for to maximize when you want to go very far without having to embark a huge mass of propellant. And finally, another thing that I wanted to present to you, I have mentioned this before, we want to be able to exploit in a circular and sustainable way the resources that we find at our destination, because what is really unsustainable is to bring everything with us from Earth. And this is ISRU, so in situ resource utilization. Oh no, I'm sorry, this slide, you looked a bit confused. This slide was about, I'm sorry, I go back. So those are the challenges about nuclear power for space. One of the biggest challenges is safety. So safety, especially during the launch, because one thing is to have a launch abort with a satellite which is equipped by something which is not radioactive, and another thing is to contain a launch abort when you have something which is radioactive. We have a good example and bad example of how this has been done in the past, but this is feasible, so this is not something that is blocking us. But of course, those are a set of things that makes the whole framework of nuclear energy for space a bit challenging. Other things are launch certification, the regulatory constraints that have to be respected for every nuclear application on Earth, the absence, for what concerns space, of international governing regulatory framework, and finally also a shortage of the radioisotope that we are needing at the moment for space mission. And for what concerns what we are doing at the moment in Europe, there is a program, an R&D program in ESA, which is called ENDURE, which is studying all the different application of nuclear power for space missions, and especially RPS. So it's very likely that a first demonstration mission is going to be on the European Large Logistic Lander, EL3, which now is named Argonaut, which is going to be our European, so made in Europe under ESA supervision lander to bring cargo on the lunar surface. And then going back to what I was anticipating, so in situ resource utilization, what can we do with what we find on the moon soil? So on the moon soil, we find regolith. Regolith is basically made of oxygen and iron or other metals. And a lot of scientists are studying how to extract oxygen from regolith. This is very important because oxygen can be used for air, but oxygen must be used as oxidizer in combustion. But what is the result of this extraction? It's iron. And scientists have been demonstrating how to sustain iron combustion in microgravity. So the image that you see here on the lower side of the slide is actually the image of iron burning on a parabolic flight, so in a sort of simulated microgravity environment. And if we can sustain this type of combustion, we are actually having a combustion which is carbon-free. So we don't have carbon dioxide after combustion, and the result of this combustion is not a gas, it's just a solid, it can easily be contained. It's basically rust. So this is a carbon-free type of combustion, and it can help us, enable us to have a circular utilization of the resources that we find, because if you're capable to provide energy with a renewable or green sources, so electric power, we are going to dissociate the oxygen from the iron, we are going to be capable to burn iron to generate more energy, and then we will be able to extract oxygen once again from the rust to keep this cycle going on and forward. So to conclude, this is a final slide in which you see lots of different scenarios and applications. The figure in the top is the lunar gateway. So it's not yet there, but we are building it. It's going to be the human outpost around the moon. And as you can see, it has big solar arrays. Then you see a rover on Martian soils, and then you see some lander and astronaut on lunar soils. So this means that basically we are going to need all and each one of those building blocks. So we will be needing to have scientists keep researching in the topics of solar array and photovoltaic source of energies, but also nuclear power and so on and so forth. So this is why it's so important for actors from the space sector and the energy sector to continue collaborate and see how we can maximize this collaboration and the things that we know in each respective field to bring both benefits for human in Earth, but also for human in space. Thank you very much.
Any questions for Antea? From anyone? The first one is always the most difficult. Yes. Okay.
So thank you for a very interesting presentation. The last slide you showed, that settlements with astronauts on the moon. When is the realistic time to see that? You know, what's the plan, and do you think that plan is feasible? So what's your personal opinion, basically? How many years from now this may happen?
I mean, I can show you a bit which are the steps that we need to go there. So first we need to start to assemble the gateway. And the gateway is going to, I think that the first part of it, Halo, is going to be launched in 2026. And at the moment, there's not yet a lander, which is a lander for crewed certified lander. So there are 2 contracts that have been open in the US to build one, but we are not quite there yet. So I don't think that we're going to see human on the moon before 2030.
Eva Schmidt from the German Energy Agency. Thank you very much. I think this is a pretty inspiring insight you give us. So my question is pretty much the type of this regolith circularity use, for example. from a German energy agency perspective, dealing with like issues we have on Earth and nowish mainly. I'm wondering, could you give me some hints how looking into the problems you have here could be interesting for energy, what is it, researchers, companies, whatever, on Earth nowish, basically, because I think the story can be told easily that, look, solar power basically came from the space industry because there was a need to get solar power some decades ago, and now it's the most promising source of energy we have on Earth. So I suppose there will, as always, be some sort of co-benefit from these exercises, and I think I would look into like circularity issues, because that's what people are understanding that we also need on Earth. So is there any obvious kind of starting point to make this a more accessible discussion, basically, for those who are not the specialized interest group?
So first of all, a little disclaimer, energy and, for example, this extraction is not really my field of expertise. I'm a GNC engineer, so I work more on the infrastructure part rather than the payloads and application and what we can do. So I'm really not the best person to answer you. But what I can say is that usually space is an R&D sort of field. So we test new technologies, and sometimes we don't know yet actually where we are going on what is going to be the benefit. And we realize this afterwards, that we can use what we have been developed to sustain life in space to bring it back to Earth. So this has been the things for the last 20 years, so we were capable to exploit what was used for ISS, etc. So I hope this is going to happen again, but I'm sorry I cannot give you a more technical answer.
Thank you very much. A quick question. What about the radioactive waste of the nuclear power? What do you thinking about that?
So how it is contained? So
how can you manage these kind of things, the waste of nuclear power?
The waste?
Yeah.
Okay, so once again, I'm not an expert in nuclear power. We have a lot of people here from ESA that are working, so I can provide you some contact later on. But actually, space has been considered a way to dispose of nuclear waste even for ground application. So there are what we call graveyard orbits. So if something is contained and it's sent very far away, you can even send it to the sun, and then sun will do the work for you, and then have back once again hydrogen and helium. But yeah. Okay, thank you. Yes.
Hello, Antea. Congrats for your for the exposé. Is a nuclear device could be installed on the lunar gateway? Would it be possible?
I think it's a bit borderline, probably, because the lunar gateway actually it could work very well with solar array and batteries because it has a good exposition to sun. So nuclear power, as it is for now, it's really it's unfeasible to rely on the coupling between solar arrays and chemical batteries, because the batteries that you would need would be so big and massive that basically we could not launch them. I think that one day we will be at the point of having, for example, nuclear engine on spacecrafts, but this is a long way to be there, and since the gateway is already being built at the moment, it's not really in the design of the system to have this type of
Okay, but more on the moon, maybe.
Yeah, on the lunar surface, this is something that is going to be, as I was mentioning, the Argonaut, which is this lander, is probably, if everything goes well, going to board among its equipment a source of energy from radioisotopes. So this is already in the roadmap. Thank you.
Thank you very much, Antea, for this very inspiring talk. And now it's time to introduce the next speaker, who is Alfonso Martinez Felipe, hydrogen champion for the university's Center for Energy Transition of the University of Aberdeen. And Alfonso is going to present us what are the energy sector's need and challenge around resilience. Welcome.
Alors bonjour, je m'appelle Alfonso Martinez-Felipe, je suis professeur à l'Université de l'Aberdeen en Écosse, and this is all the French I can speak. But I'm really proud of myself because both my wife and my 10-year-old daughter speak French, and now I can say that I have given a talk in French. Well, I started a talk in French in Paris, just a few meters away from the Eiffel Tower. Not many people can say that, definitely not my wife. So today I'm going to talk, I'm going to wear a double hat. On the one hand, I'm going to be an academic, so I'm going to lecture you to death and bore you to death with some slides about the energy transition and how the energy transition can actually help energy resilience. And later I will talk about my role as part of the Aberdeen Renewable Energy Group, which is an association with different industries and stakeholders in Aberdeen. So back to Earth, I don't have pictures of the moon here, but I do have nice pictures of Aberdeen University, which is in the north of Scotland. In a typical sunny day, we have a lot of them up there. And yeah, fifth oldest university in the UK, founded in 1495. And I always say that some of my colleagues were already there when it was founded because they never retired. And I think that the main point of the university is that we are a very multidisciplinary center. So we do have people from different backgrounds, people from different disciplines, and we work around the energy transition from a multidisciplinary point of view. This is what we call the energy quadrilemma. And again, I'm going to just throw some ideas here for you guys to think about opportunities for collaboration. We all know about energy security, the importance of sustainability, which we talked about yesterday in plenty. The fact that it needs to be economically viable, so it's all about the money in some cases, but also the kind of fourth leg of the chair is the social acceptance and the fact that we get into a just transition, so it's actually fair for communities. And then we engage with people and we explain what we're doing. This is kind of what we're doing here today. Well, the first question is, what is energy resilience? What would you call energy resilience? As a good researcher, I made some research myself, and I reached the conclusion that energy resilience is what we do to eventually avoid this, okay? Which is eventually going to a blackout, right? So if this happens, what we do to avoid this and how we recover from this situation. So if we do this in a PowerPoint screen and we go black, it's okay. If we go to kind of bigger scales, we have a problem, right? And I guess someone gets fired. So the idea is how we can avoid this situation, how we can keep our systems up and running without having this situation. So there are different causes or potential threats for energy resilience, and I've just picked up 5 of them here. Obviously, climate change and weather disruptions, storms, etc., can cause energy systems to fail. I read somewhere that in the United States there were around 21 superstorms last year or a couple of years ago, causing a lot of disruptions. The other one you may be familiar to is grid saturation, which is more, kind of the electrical guys here. The other picture represents instruments getting old, right? So failure of instrumentations and equipment. And the last two in the last row are actually quite interesting. One is cyber attacks. So obviously we are going into the digitalization era, and data is extremely important for energy systems, but it can be a threat too. And the last one on the right side here is what I called human stupidity, which is eventually, the cause of wars and attacks which are deliberate. And this is just an example of one of the latest attacks from Russia to the Ukraine energy system, which is obviously causing a lot of pain. So, again, I'm a lecturer, so I cannot avoid just lecturing a little bit, but don't worry, because you can always leave the room. My students cannot, because they have to pass an assessment, but you can leave if you get bored. But eventually, this is a reflection of what we normally would have in a classic energy system, when we have a centralized source of energy connected to different points in different grids. And obviously, the problem happens when we have a disruption in the transmission of the energy, or we have a blackout, as I said before. We always have kind of backup plans, like, for example, generators, normally using diesel because eventually it's quite high intensive, or microgrids, which have the advantage that we can use renewable energies. And this is something classic, and some of you guys are experts, so far know more than myself. But the benefits of renewable energies is that actually we can delocalize the production of energy, so we have different points of energy sourcing, but also diversify the origin of these sources. And then we can talk about different primary energy sources, including wind, biomass, solar, geothermal. And then we get into a map when we have better connected systems, so it's not so crucial that some of these interconnections are kind of breaking down. But also the fact that even isolated systems, like the point in the middle of the scheme there, can have its own energy source, so it's not relying on someone else to do that. And the next step for that is that actually we will need to somehow store the energy, as we were mentioning in the previous slide when Tina was talking about energy storage. And choosing the right energy storage system is crucial depending on the application. So energy storage as a way to buffer the energy is definitely something that we need to take into account when we deal with renewable energies, because renewable energies are variable with time and position, so we're going to need to take that into account. So the question is, what sources or what tools we have to store the energy, what different energy carriers we have. And again, this is something that you probably know already, but just wanted to reflect on that. Heat is a classic energy vector. I've been using in the Industrial Revolution, but it's not a really good one for certain applications because it's what we call a degraded form of energy, right? It can be dissipated very easily along long distances. So we can also use electrons. This is what we do eventually in the grid. So we transport the energy in the form of electricity. And well, storage of electricity can be challenging, as we saw in the previous presentation, because we need a lot of weight to store some amount of energy there for batteries. And we can also go back to the classics, which are the molecules, right? So we can store energy in the forms of little balls and atoms and molecules. That's what we've been doing for decades when we're using gasoline and diesel, obviously, but we want to get away kind of from this scenario, so we can use more fancy molecules like hydrogen and ammonia, for example. I know some people are very skeptical about hydrogen, but I will give you a couple more of slides later on to discuss some of our ideas. And it's relatively easy to transport and store molecules, at least on Earth, right? So we go back to Earth here. So within this scheme, again back to my slide a few minutes ago, what we can see is the energy transition and the use of renewable energies is giving us some opportunities to tackle energy resilience, right? Because we have some ideas here that we've been talking in the last couple of days, like, for example, access to markets, economical viability, but also a diversification of the energy sources when it comes to energy resilience and energy security. And again, at the bottom of everything is how we inform our societies, our colleagues, our neighbors about what we're doing, the opportunities they have to engage with us and be part of this energy transition. So this is how I see it. So the energy transition, which is, again, offer a really good opportunity to cover energy resilience, is a global thing. So we need to take into account everyone, communities, industry, academics, companies, and different sectors as well, but also communities which are isolated too. And different countries are already understanding that because it's a global problem, we need a global solution as well, and we need to work from a systemic point of view. And I got a nice conversation with Alireza yesterday about system approaches, which is crucial in the UK. We are an island. Some people haven't realized about this yet, but we are an island. And so we have a good opportunity to actually have different clusters and different collaborations to develop this energy system approach. And you probably don't see a lot of things here, but these are examples of clusters that either the UK government or different other agencies are trying to push for. And the idea is to use the opportunities regionally to create this sort of community or energy community where the waste of someone may be the feedstock for someone else. And we're thinking about CO2 generation in power plants that could be used for storage, CO2 storage underground using depleted oil fields, for example, underground storage, but also the usage of CO2 as a feedstock to create new biofuels, for example. And this can be done at local level, but the challenge is how do we connect these dots, and we do it at national level, European level, international level, intercontinental level. And that's what I think space, as space agencies, space technologies can play a major role, because there's an opportunity to go into a planetary scale. So I promised I was going to talk about hydrogen. I want to make clear that, I'm pro-hydrogen, but I'm not being paid by the hydrogen lobby, as they call it. I'm open to business, if anyone from the hydrogen lobby is here. But I think hydrogen is going to be part of the solution, maybe in a bigger or lesser extent, depending where you're in the world. Is one potential energy vector, but also a brick which we can use to create new molecules, because it's eventually in our bodies, in everything has hydrogen and carbon these days. Now, the wonder of hydrogen is that either you like it or not, it doesn't have a carbon atom in the molecule. It's very small. And it means that it's not going to generate CO2 when you use it for energy generation. So it's not going to be a carbon footprint, a direct carbon footprint at least, when we use it for energy applications. And there are a lot of challenges with hydrogen, the fact that it has a low density in atmospheric conditions, because low pressure, etc., and transportation can be a pain as well. So a lot of countries in Europe and the US have their own hydrogen strategies. I think Germany is working on that as well. And eventually the idea is to integrate the different stages of hydrogen. In Scotland we call that make it, move it, use it. So we would have generation of hydrogen from different sources, diversification of primary sources, which would be kind of the lowest role there when we have hydrogen produced from renewable sources, green hydrogen. Potentially also hydrogen generated from natural gas, capturing CO2, which would be what we call a blue hydrogen. This is again another source of controversy. But also hydrogen generated from nuclear energy, which is, guess what, it's pink hydrogen. You wouldn't say that, right? So this is a Barbie moment. Pink hydrogen generated from nuclear, right? And I can tell you some people in Ukraine are really interested to use pink hydrogen as an energy vector too. So there are opportunities here as well to have what we call a rainbow of hydrogen, a multicolor hydrogen. So this strategy, which, put in different ways, compresses all the stages from a generation of hydrogen, then transport of hydrogen, storage of hydrogen in different forms, either as gas, pressurized gas or liquefied, depending on the application, maybe for long transport. But we can also think about upgrading of hydrogen to other compounds, like ammonia, for example, or liquid organic hydrogen carriers. And finally, the usage of hydrogen in different sectors, like, for example, transport applications in fuel cells, which has been used for in Apollo programs in 1960s, 1970s, so it's nothing new. But also heating or industrial power as well. So there's a lot of application, and we have a great potential in the UK to store this hydrogen underground in depleted oil fields after different technical assessment. And this, what you can see there, this is something I used in Matera last year, I think. It's not the map of the London Tube, but, yeah, you could say that. It was a question in one of my exams for the students. They hate me for that. It's actually some of the plans that the Scottish government have for the system integration for 2030. And you can see, well, you probably don't see much there, but you have different energy sources like floating offshore wind, where you can have an energy entry there, but also still gas extraction, oil extraction. So this is a transition. So we are not still in net zero yet, but it's a kind of a way forward. Biomass as well, this is the kind of the green light over there. And then you got these stations when eventually you have a transformation of energy vectors, and then you come from one to the other, and then you generate other things, like, for example, hydrogen, which will be the orange line. So this, I like this picture because it got a lot of colors, but also because it shows you, you know, the need to have an energy system integrated to make the best of it. And going even more local, as Seraham was wearing two hats, this is a picture of the Aberdeen airport, and as I said, I'm part of the Aberdeen Renewable Energy Group. Aberdeen has a long legacy on oil and gas because we are very close to our neighbors in Norway. We met someone from Bergen yesterday. We also share the weather. But the good thing is that we have a lot of oil and gas fields there, and we have a lot of exploration. And the whole region is reinventing itself into the renewable area. So apart from using, you know, the oil and gas at Citrus avenues for years, now we're trying to use some of our other natural resources. So again, it's really windy in Aberdeen. So we use the wind to generate electricity and wind farms. Offshore wind is really big in the whole UK, but in particular in the North Sea. There's a lot of licitations already. And there's actually a competition between, for example, carbon capture and storage and wind. It's amazing. I mean, the North Sea is starting to be really crowded, guys. So there's an opportunity for investing there as well, too. But the idea is that in Aberdeen, we've created an ecosystem when we can have one of these clusters I mentioned a few minutes ago. And we have what we call a hydrogen hub, which is a project participated by the Aberdeen City Council, the universities, BP, and other companies as well in the energy sector. And the idea is that we combine the generation of hydrogen from renewable sources, the generation of hydrogen from natural gas for the time being, carbon capture and storage, and then we try to pipe out that hydrogen into other regions of Scotland and the UK, potentially exporting them. And we also have the possibility to store it underground. And as part of this development, we're also creating digital tools to study hydrogen generation, but also the use of other renewable energies. And these are a couple of pictures I took in one of the seminars done by the National Decommissioning Center, which is working in principle with oil and gas, but now moving into renewable energies. And I wanted to finish these last couple of slides talking about digitalization, because I think this is really interesting for this sort of commercial days. So this is a map of the CO2 emissions taken based on the data we have. Obviously, you know, using satellite communications, this is going to improve. And also you guys may have companies already working in the area. And almost last but not least, my colleague, Dr. Raffaello Secchi, and I are trying to put out together some projects to actually work on the energy sector here with ESA. And this, he passed me a few slides, so they are very technical, and I don't understand some of the things here, so don't ask question about this, but these are some of the projects that have been working in Aberdeen in terms of satellite communication. We have a very, very powerful group there. And some of the EU projects that have been funding this interface between the space technologies and the energy. And that interface is something I think we really need to explore. It's one I think we all are here. In particular, we have identified a few challenges and some goals for where we would like to explore in future projects. And I think the idea is that the two sectors, or the kind of the two areas, is, the data, the space, and the energy need to speak to each other, and creating some standardization is going to be crucial. And again, as a good academic, I always tell my students, you need to finish with some conclusions, so I'm going to do so, right? Eventually, we've seen how relevant energy resilience is, but also the opportunity we have around the energy transition and the use of renewable energies to tackle that. So I think both energy resilience and energy transition have challenges, but also synergies, so there are opportunities. And digitalization and the use of space technology can be really helpful. And I think the most important thing to say for me is that apart from all these challenges, as I said before, and threats, we don't know what's coming next. We're going to face a few years of certain uncertainty in general. So we cannot sort of underestimate human stupidity. So we need to be ready for what is coming next. And I think we need to be working on this now, trying to anticipate to that. And I would like to close up with some acknowledgements to my colleague Rafael and all the guys from ESA, Federico particularly for his patience with the slides. And also I'd like to, acknowledge yourself for your patience and your time when you listen to me, and also I'd like to acknowledge my wife for letting me come here to Paris in the middle of the break. So thank you very much, guys, for your time.
Thank you very much. Since my job description is Director Hydrogen and Synthetic Energy Carriers at the German Energy Agency, and before that I had a career in research looking at resilience and designing energy systems, particularly with respect to power grids, I completely feel what you were talking about. My question is, I think everything is correct, and we could delve into how space-based applications can be of huge help here and so on, and figure out an ideal system solution. My diagnosis is that in order to implement this and get this in reality, basically, to build it and operate it and so on, the biggest obstacle is the way laws and regulations, incentive structures are being drafted, because it's different ministries with different logics and different silos. And also the whole line-bound infrastructure like power grids, everything that happens there is governed by the way that grid fees are being collected and distributed, and then the cost structures and so on and so forth. And I've tried for a couple of years to get reforms there, and so I left the field because I felt it's not possible with the situation at the moment, and with how the way European regulators and so on are organized. Do you have any idea on how to deal with this? Because it kind of hurts to look at the elegant solutions we have and then facing the reality with so many intertwined legal actions that would need to be implemented in a coordinated way. So it would really need a task force, and also the willingness to substantially reform the grid structures or grid fees and all of that, like everything that ESA does, for example. And I don't see it there. And also there's a huge resistance of status quo actors, because there's a reason why grid fees are designed in a way they are at the moment, and there's still a lot of actors that actually benefit from that. So not only is it hugely complex, but also there is a huge resistance to status quo. Thank you.
I completely hear you. I mean, it's a well point. It's so difficult to get politicians to talk together, and so between the same countries. So just imagine within countries. If I had an idea of how to do it, probably you and I would be in the European Parliament right now, right, selling some idea there. But so I think regulations are. I'm not a regulating guy, so I'm not coming from law, but Part of the story about Aberdeen is that we work with the School of Law as well on regulations or hydrogen. My experience within the UK is that at least the government there is trying to push for an agenda on regulating, for example, hydrogen. And at the moment we are eventually, if I'm not mistaken, taking just the regulations that were put on place for natural gas, like decades ago. So it's taken a long time, and we're missing opportunities when it comes to regulations. I think you're right. We need to put together a team that works across different countries. I think the European Union is a good place to do that. As you know, the UK was a former EU country, but we decided that we were better off because we're an island. But I think nothing of this can happen. I mean, obviously it can happen locally because, you got the councils, you got the people, the communities. But when you go to joining out all the dots in a national level, you need to have regulations that go across the regions and the nations. You need to go as a country. So I think the answer for that is just keep on trying, just keep, do regulations at European level that can actually overrule what's happening in the different countries. But at the same time, the national strategies are still national strategies, and obviously you're doing your job in Germany. I think everything that I said for the UK, I guess it's going to be not miles away from what Germany will do. Probably the point will be more in consumption because my understanding is Germany has a really strong industry and sector that can absorb this hydrogen, whilst I see the UK more as an exporter of hydrogen because we're going to have a lot of wind and a lot of power to develop this hydrogen. And then the point is going to be how we transfer the hydrogen, in this case, or energy vector, whatever we used. What's the cost of that? It's not efficient for the time being, or is it just better to use another source for this case? But if you have an idea of how to do it, just call me, and then we can start, some business together.
Hi, I have another question. Thanks again for a really great talk. I'm also very familiar with the hydrogen dilemma because Norway could provide Germany with hydrogen, but they just want natural gas. It's hard to change the system. My question is, you ended up on the digital challenge, and which was really important. And we have this dilemma at the moment that the big American digital companies are placing their data servers in renewable countries like Sweden and Norway to get access to green power for their digital revolution. So actually the digital companies are part of the problem as well, on the energy problem, right? So rather than just saying we need better data, is there a way that you can provoke the big digital companies to buy into clean energy and to actually fund the transformation?
That's one of the challenges that are difficult to see, right? You think that people are going to help, and then it becomes a problem. I think regulation again is the only way you can do that. I mean, I'm an optimistic person, and I think next generations will be more concerned about like climate change because we are already seeing the effects, and I see a generational shift. But for the time being, as you say, I mean, we are still there. So I think what we have to do is just to keep on regulating the energy sector at European level. I'm talking about Europe because that's what I know. I know the US is a completely different story, but and try to maintain the values of this good old continent, which seems to be old-fashioned in some parts of the world. And I think this is the perfect spot to do it here, just so close to in the heart of Europe with so many people from different countries. But we talk, and the people who take the decisions are actually in the parliament, and there are a lot of lobbies and very, very powerful people who are probably not sitting in the room, or maybe yes, I don't know. Yeah, I'm still open for business if you want to lobby me. But the point is that there's a lot of conversations and there's a lot of frustrations as well around the energy transition, because now in the UK you can see that even the party in the opposition is shifting from their own green agenda and they say they're going to promote again oil and gas for a few years to come, because they fear they're going to lose votes. And I mean, this is what we have. Our system is not perfect. We got a democracy, and you know, politicians are going to rely on voting, and they're gonna rely on what people think is the best. And that's why I think social awareness is so important. We need to educate the people. We need to educate the persons that are gonna vote, because they are gonna have the power at the end of the day, you know. And if we make them understand that it's crucial that we go into that sooner or later, I think I have the faith to see that then we will put in place regulations so that the digital companies will actually, you know, become part of the solution and not part of the problem. Again, one of the problems of globalization is that you can have this sort of issues as well. But, yeah, thank you.
First of all, thanks a lot for this education, and I think, like you are saying, that we really need to raise awareness in the public, and it will help the politicians to take decisions. I would like to come back on hydrogen as an end user in my past job of hundreds of tons of hydrogen. I have some experience on the subject, and I think that it is really becoming, it will become, I'm sure of that, the secondary energy carrier altogether with electricity. And why aren't we more scared or cautious about what China is doing? Because they are really moving very, very fast with respect to the regulation, to the political decisions. And already there are a lot of countries, for example, in Northern Africa, which are switching also to hydrogen on the basis of what is currently making in China. They are currently the first producer of hydrogen, including green hydrogen, at a cost which is lower than gasoline today in terms of energy. And we are continuing to discuss, and we don't look at what is happening on Earth. So here, it's space people. We see the Earth as a very teeny planet, and we should be aware that we should have a look outside of Europe in order to manage our future.
Yep, no, I totally agree. I mean, we're wasting time. It's that simple as that. Again, back to the democracy thing and the social awareness. We are a democratic society. I'm talking about Europe now, and obviously because we're in the context of the European Space Agency. So we obviously tend to have this consultation, and we talk and we discuss regulations, which are important, but we also have to consult the people, and then we need to be aware of the environmental impact of certain projects. But at the same time, other countries, other powers in the world don't have these mechanisms. So they just, someone decides A, they go for A, and that's a kind of inevitable if we want to live in a democratic society. But at the same time, we need to make aware people what the urgency is. We are already losing a lot of market opportunities in terms of the hydrogen sector. And I think it's frustrating because at the same time you see the amount of money that the Europe Clean Hydrogen Partnership has, for example, and they really have a lot of money put into projects. I've seen some of them, but in general in hydrogen there's already a lot of investment at European level, but we're not still getting to that point when we have a market. And I think to be honest, the main limitation is connectivity between the different countries in Europe, because we have everything. We have the sun, we have the wind, we have geothermal, we have the power to connections to the gas as well if we need it. We need to use it, we need to act quickly. But that again is about educating the people and making sure that we take the right decisions in the right time. Well, thank you very much for your questions, and it was really great being here today.
Thank you very much, Alfonso, for this very, very useful presentation. And now it's time to introduce the next speaker, Davide Coppola, who is going to give the space perspective. How can space asset tackle the needs and the challenges that we have just seen? Welcome.
Thank you, and good morning. Good morning, everyone. So, well, I will try to give some highlights on space applications in relation to energy resilience, addressing some of the challenges that have been presented today. About myself, I'm Davide Coppola. I'm the head of the Space Application Initiative section at ESA, and historically, since a decade, we've been working a lot with energy players, main utilities around Europe, and also globally to define opportunities for space application to contribute to their challenges, primarily through the Business Application Space Solution program that was presented yesterday. So, first of all, I try to put things in context. Clearly, secure electricity is a fundamental pillar of our economy. That's simply because we live in a digital world which relies on electricity. So our economy cannot simply function without electricity. That's a fact, and that's something that we see more and more looking at the expansion of electricity to address sectors such as heating, cooling, transport, communication, and many others. So yes, it is important, and it is important to guarantee robust electricity supply. And the challenge there is that the energy sector as a whole has been undergoing to fundamental transformation over the last decade. It went from a very centralized approach relying on a relatively small number of big electricity providers or electricity generation source to the total opposite concept in which we have a very high number of different types of energy generation, many of them related to renewable and of different sizes. So this, of course, creates an opportunity, creates challenge, and they are all related to the topic of energy resilience, as we'll see in the next slides. So, Alfonso, as you did, I also try to put things in context and trying to look for a good definition of what energy resilience could be. And the good news is that we are aligned, but I don't have the black slides as you did. So clearly, resilience is energy resilience refers to the ability of the energy system to survive and quickly recover from extreme and unexpected disruptions. And going a step further, normally when we speak about energy resilience, there are two types of issues that are often looked into. First of which is climate resilience, which is the ability of the system to anticipate, or to prepare, and also to recover from extreme weather events, so events related to climate. So that's, of course, a big topic, which is primarily related to infrastructure, of course. The second topic, which was also mentioned before, is cyber resilience, which is the ability of the system, in this case, to defend against cyber threats. And there is, of course, also a third dimension of this, which is related to what is also called energy security, which was also introduced in Alfonso's presentation, which is indeed the possibility or the capability of providing energy at affordable prices. And that's, of course, a topic which is gaining momentum in the current geopolitical situation. In the next slides, I will try to highlight some opportunities for using space applications across each of the different teams, and giving also some practical examples of projects that have been supported through our Business Application and Space Solution program. Clearly, these will be just few examples because we have hundreds of activities that have been working in this kind of domains, but I just try to pick up a few of those that could explain practically, the application in this context. So this is a portfolio of 61 activities, the ones which I used basically to take this example. So those were activities carried out in the last 5 years, so to speak, and corresponding to an investment of these of about 30 million with co-funding and from industry, space industry, and potential customers of about 12 million. So the first topic I would like to introduce is a topic of climate resilience. So I mentioned already early on here the main issue that we have is protecting the infrastructure, the energy infrastructure. So which kind of services, which kind of role can space technology play in this context? And well, there are a few and very strong use cases for using space technologies in this context. I would start with the first one, which is the use of satellite imagery, so Earth observation data. Earth observation data, different type of Earth observation data, can be used to pinpoint infrastructure risk. So infrastructure risk in relation to stability of infrastructure, but also in relation to external factors such as, for instance, vegetation. Many of you might be aware that vegetation management has been the topic and a big concern for the utility sector due to the risk that vegetation can pose to the power lines. And on the space industry side, many applications have been developed using satellite observation data to help and assist with these kind of issues. The second aspect, which is still related to Earth observation, is the use of satellite data to enhance forecasting capability in relation to weather. So it's weather forecasting with focus on extreme weather events. And the last but not least use of space technologies that one could think of is the use of satellite connectivity during the emergency phase. Some of you might know that during an emergency, let it be, an energy emergency or any sort of emergency, that typically the very first thing that collapses is the terrestrial telecommunication network. So if you try to communicate using your smartphone with 3G, 4G, 5G, normally during an emergency this would not work. And this is for many reasons, first of which that the same infrastructure, communication infrastructure might be not available, or there could be a saturation of the terrestrial infrastructure network. In that sense, satellite connectivity can help providing, again, a tool to support with connectivity during these phases. A few examples, and actually some of the companies mentioned in these slides are here today. And I think here what I would like to highlight is also the shift that we have been experiencing in the context of space applications for climate resilience. I mentioned earlier on that vegetation management has been a topic of interest for utilities, and I well remember when we started the conversation with NCE back in 2016, that was really that topic that they wanted us to address and look into. So, as I mentioned before, a lot of work has gone into this, leveraging satellite Earth observation data to predict the risk of vegetation interfering with the power lines. Initially, so if we go back maybe by 10 years, the main challenge or the main objectives of those applications was to predict vegetation growth and assess the distance between the vegetation and the power lines. So this is the very old story. And now the new products like the ones that I mentioned here, the new applications, are tackling the next challenges, which is understanding the risk that vegetation can pose to infrastructure following extreme weather events. So it's no longer about measuring, understanding the distance between vegetation and power line, but it's really about understanding the level of risk that this could create when extreme weather events happen. So this is a shift that we've been seeing a lot in terms of applications powered by space technology, and that's really what we see happening more and more in this domain. Moving on to the next challenge, just a few words about energy security. So this has been a typical field of application, so in relation to using space assets for renewable energy. And the low-hanging fruit, historically, has been the use of satellite imagery for helping the so-called bankability of the renewable energy plants. So to keep it simple, satellite data provides, of course, weather conditions historically, so you can go back by decades or more. And as we know, renewable energy is highly dependent on weather information. So by knowing the weather patterns historically, one can translate these weather patterns into power generation, which provides indication on the level of revenue that could be generated through a future installation of an offshore wind farm, for instance. By knowing that and comparing that with the cost of setting up and the operation cost, one can understand if the plan is economically viable. So that's the so-called bankability. So this use of satellite Earth observation has been pretty much mainstream over the last 15 years, I would say, or so. And this has been also used not only for the financial part, the bankability, as I mentioned before, but also to understand the environmental impact that renewable energy could pose to the environment. So this has been another domain which is normally very much provided by the same kind of providers. Next to this, there is a role for satellite connectivity in the context of the installation phase, primarily the installation phase of renewable. Thinking of an offshore wind park, for instance, normally during the installation phase, terrestrial communication might be lacking, but terrestrial communication, again, I'm referring to 3G, 4G, 5G, could be lacking, could be non-existent, or if it is there, might be not sufficiently reliable. And the installation of this kind of offshore wind parks, but the same holds true for other types of renewable energy, is logistically extremely complex. So one would really need to have a reliable telecommunication source in order to make it work properly. And satellite navigation is, of course, the positioning technology, so Galileo or GPS, that is used extensively for the monitoring of the logistics around these kind of installations. And yes, there are examples of this kind of utilization of space which have been supported through the BUS program. The first of which is a very old one, is a project called Comfort Offshore, which was implemented by OHB Germany. And this solution actually looked into the complexity of the logistics around offshore wind farm installation. You might know that the installation of an offshore wind farm is extremely complex and involves very different items, very different pieces of technologies, very different suppliers with very complex value chain. So, and before the actual deployment of the offshore wind turbine, there are several steps to be accomplished, and each and every step can add delays to the eventual deployment of these assets. So this solution, Comfort Offshore, actually looked into the monitoring of the supply chain in relation to offshore wind farm installation. And it was able to monitor, first of all, the availability of the different items that are needed to set up the plant. And by monitoring potential delays in this process, it was eventually able to forecast the end impact of this delay with regards to the final installation. And the trickiest part there is that the last part of this installation involves vessels, which are specialized vessels to support, to perform this kind of installations, which are notoriously extremely expensive. So on the one hand, there is an economic factor there, which is to make sure that the time these vessels could be properly used. And to make things even more complex, offshore wind farm installation, which is where Comfort Offshore was used, are highly dependent on weather patterns. So you cannot simply install an offshore wind farm regardless from the weather conditions. So this system eventually was factoring in delays throughout the value chain and weather conditions to anticipate the impact of any possible delays in the installation of these offshore wind farms. What is the role of space here? Clearly, satellite navigation with regards to the logistics part of things, and the satellite connectivity was used during the offshore wind farm installation, so for the management of operation happening at sea. Next to this, there are several examples related to the bankability of energy asset, what I mentioned before, which is primarily the use of satellite Earth observation data to understand under which conditions a renewable energy plant could become economically viable. And there again, if we were to go back by more than 10 years ago, I mean, initially, we saw several applications looking into the bankability, primarily for solar and wind, a little bit also following the trend of renewable energy, and hydro energy as well. And this, again, is an example from a company called EOMAP that is looking into utilizing satellite observation data to predict the snow water equivalent. So we went from I would say, from the typical renewable energy sources to newer and riskier if we want renewable energy sources where we have applications such as MESPAC, Wave for Energy, that look at again into utilizing satellite observation data, in this case for predicting the development, the bankability and development of new ocean energy applications. So again, it's a similar model, but applied to different types of renewable energy, newer and riskier, I would say. Is this the end of the story? Not really. Because again, when we think of integrating renewable energy, as I mentioned earlier on, the utilization of the renewable energy, of course, has implication in the management of the grid, as we have been saying in these 2 days. And as I mentioned myself earlier on, this means that the grid that was initially designed to function with very few number of energy producers is being exposed to a massive change where you have a very large number of energy generation points with variable rate of generations. So that means that in order to keep the grid working, we need to work on making the grid smarter. And we have projects such as Mowgli that have been working into this. So these are really about digitalizing the grid and working on demand response aspects of the grid. The interesting thing about this project, Mowgli, is that it didn't start as a project dedicated to demand response. It actually started as a project to support microgrid management in developing economies. So it was initially designed to address the Indian market. So microgrid is a small electricity island, so to speak, to keep it very simple, can be very remote. So the first challenge that normally one would face is to make sure that this grid can be maintained without the need of going physically there to check the correct functioning of the grid. So there is a role for satellite connectivity to play in these kind of settings. And that's what Mowgli did initially for microgrids in India. Then this concept moved from developing economies into commercial market. So they exported the same concept into commercial microgrids in the US, where the anchor customer is ABB. And then the same technology has been actually repurposed, extended to address demand response partners in the traditional context of the larger grids. So this is also an example on how these kind of applications can evolve to address the needs of different markets. And well, last but not least, cyber resilience. Well, if we would have thought that with the last slides we have covered the issue because we are finally digitalized the grid, we have supported the integration of renewables, well, there is actually a last element of this puzzle. By us enabling and supporting digitalization of the grid, we are implicitly making the grids more vulnerable to cyber attacks. So of course, there is another aspect to be looked into, which is the utilization of space data, space asset in response to cybersecurity. And there, the typical application has been the use of satellite connectivity in the support of cybersecurity risk. Why? Satellite connectivity is by design a secure network, so one could think of using it as a main connectivity network whenever cybersecurity is of paramount importance, or as a backup network in case of major failure in the main network. So this is an area where industrial players, but also utilities, are investing and considering opportunities, which are, of course, extremely important for safeguarding their stability of the network. It's a risk that is increasing over time, and it goes together also with the physical attack to the grids, where satellite observation data, for instance, can play a role. From a space perspective, this is not the domain where we've seen the largest number of activity, so it's actually one where there have been a few attempts to develop new services, but it's not the biggest one in absolute numbers. And one of the samples that I have here was actually related to the protection of time-stamping information provided by a global navigation system solution for utilities. You might know that synchronization is a fundamental aspect for the energy utilities, and this often relies on Galileo and GPS. However, these kind of signals are also susceptible to radio interference, which can be done intentionally or unintentionally. Therefore, there is a huge concern, a huge topic on how can we actually protect and make sure that these timestamping information are not corrupted. And that's what basically this company did, trying to use the authentication feature of Galileo to really shelter the timestamping information provided by GNSS. So, well, what I've tried to give you today is really a kind of helicopter view about different application and opportunities that we have seen in the last years through the BUS application program. And in these slides, you basically see also the approach we've been following to stimulate these opportunities. As I mentioned earlier on, we have been working with utilities to really understand what they are up to, what keeps them awake at night, and really define funding calls based on their requirements, offering opportunities for space industry to propose solutions addressing those. This has resulted in many of the activities that you've seen before and more to come, like it was presented already yesterday. And in this context, recently we have set up also an energy task force, and with some of the members actually are here in this room, which has really the ambition of creating a collaborative framework for the utilities and associations to think strategically about what is needed, what is required to innovate sustainably the energy sector, and which of those challenges could be also addressed by using space technologies and data. The reason why I mentioned this slide is not only related to the work we've been doing in business application and space solution, but it's also related to the next slide, which is the conclusion, the conclusive one. So just to try to summarize here, today we're looking into different types of space applications in the context of energy resilience and energy security. So I've seen how space technologies and data and services can contribute to the different challenges, giving a couple of examples. So, well, if you would think that, okay, there is a very good news today that space technologies could do everything, I'm afraid I have to disappoint you, because that would be a very wrong assumption. First of all, and this was also mentioned yesterday, when I speak about space applications, we are referring to the integration of different technologies in which space is a part of the solution. So it's not about what space data can do, it's about what space can do together with other technologies. But taking it aside, the issue of what space application actually mean, the point I'm trying to make here is that innovation is an aspect, but it's not the ultimate answer. And I go back also to what was mentioned before. I mean, clearly technology can do a lot to address some of the challenges related to energy resilience, but most of those challenges to be addressed in an efficient way, in an effective way, requires cross-sectoral cooperation. It's not about innovating, it's about innovating with a clear mindset. It's about involving regulators, it's about involving commercial players that can sustain the economic growth of this service. And I think the perfect example that we saw before is the use of renewable energy, right? One could think that renewable energy is a fantastic asset, and it is actually, but it creates issue in terms of management of the grid. So you try to solve one issue, but you are at the same time creating a second issue. And by trying addressing the issue related to let's make the grid smarter, we are creating another issue, which is cybersecurity. So again, these kind of issues cannot be addressed in a silos approach. They really need concerted actions, cross-sectoral actions to eventually deliver the real impact. And that's the link to the task force, which I mentioned earlier on. Really, the stakeholders and the initiative that we have launched last year goes actually in that direction, the direction of establishing cross-sectoral cooperation involving different players from the demand side of the value chain, which share the goal of innovating with the purpose of supporting energy stability and resilience in the short and medium term. And with this, I would like to conclude and thank you all for your attention.
We have 5 minutes for question and answers. Any questions?
Thank you very much for David for the presentation and the input. Maybe I didn't get a part of your presentation, otherwise my question would be, I totally see that space application can help the resilience of the energy systems on the ground, but what about the resilience of the space-based applications, the satellites as a critical infrastructure? When we rely on them, and something happens in orbit, we will have the problems on the ground too. And if I'm not wrong, on the day Russia attacked and started the war against Ukraine, at least in Germany, a lot of windmills were not working because of the communication, which did not happen. So can you give some words or insights to resilience of space application? Thank you.
Thanks. It's a very good point, and actually it was not mentioned in the presentation. So indeed, we are looking into this as what space can do to address the challenges of, in terms of energy resilience, right? But at the same time, you are fully right in saying whenever we use new technologies, you are unavoidably creating the risk for becoming somehow dependent on the use of these technologies. And if they are not available, let it be space or no space, then you have an issue. So I think the answer to your question is that, first of all, in order to ensure the robustness of this kind of application services, one will have always to look into avoiding single point of failure, right? So this is true when we speak about the use of satellite imagery. If your service is relying on one satellite, on one supplier, you are unavoidably becoming dependent on the availability of that asset. So this is the very first point. The second point goes back to what I mentioned before. These kind of applications, they normally work as integrated solution. So clearly there are different items, space and non-space, that are collaboratively working to deliver the applications that are needed from the energy sector. So by working with this integrated approach, one is also minimizing the risk of dependency on individual assets and pieces of the technologies that are used within this integrated solution. But clearly, as the main point here is really working on the redundancy and avoiding single point of failure to make sure that the service can continue working regardless from any kind of risk on the space segment as well.
My name is Oscar. Thank you for your... I work for a grid operator, Elia Group, operating in Belgium and Eastern Germany. And spot on all your presentation, we fully agree. I would like to make a note. You mentioned an event that occurred in Germany. Satellite communication solutions, there are many types, public, private networks, and depending on how you deploy the solution, you might generate risks. So in that case, specific case, our operator of the wind farm decided to use a public satellite network where security was not certain, and that happens sometimes. However, we at Elia, what we are doing is deploying a private satellite network where all the assets are in our facilities and we have full control. The only thing that escapes to our control is the satellite itself. All the rest is on premises. So there are many ways to deploy networks and to guarantee security and resilience. And the point that I would like to ask to Davide is that, yeah, number one, thank you to you and ESA for the efforts you are making to create such a vivid ecosystem of suppliers, new suppliers that we need urgently to improve, as you say, the resilience of our assets and secure the supply of electricity. Now, we are trying to approach, as you say, there is not just technology, there is a market understanding, there is the way we do business, the way companies do business. There must be a meeting in the middle. There must be some effort made on our side, but on the other side as well. So from your perspective, having spent several years, what do you think can help to energize our collaboration between space and the grid operators?
Thank you, Oscar. It's a very good question with, I think, several answers. And deserves probably a talk over maybe one day or so. But I think the very first point, if we speak generally about utilization of space data and the space services in the context of the energy sector, there is one fundamental challenge, which is awareness. And this is something we've been working on from an ESA perspective since many years now. And there is a need to make the energy sector aware of what space technologies could do, space application could do for them. And at the same time, there is a need to sensibilize the space sector, the downstream space sector, upstream and downstream, to really create solutions that are bespoke to the energy sector, because the one-size-fits-all solution simply doesn't work in the context of energy utility. This is what I've learned myself over the years. And I don't know, Oscar, if you find yourself in this situation, this challenge.
I totally agree with you. Is that, yeah, we find how it's important for suppliers to understand how regulation, we talked about regulation before. Regulation, I think, it might be hideous sometimes, but it enables standards. Regulation enables safety. The safety utilization of power, electricity, is made thanks to regulation. So it's necessary. But at the same time, it's not carved in stone. It can evolve. But to evolve in its inputs. So we see how TSOs or grid operators are regulated by national regulation, European regulation, but there is a way to influence that regulation when suppliers of services that are vital for our operations get close to us, and we find ourselves in the middle. It's neither our way or their way. What Davide was saying is that, yeah, we need suppliers to understand that we are not an enterprise customer. We are critical infrastructure operators, and as such, we have a specific way of operation. Our budgets go in a certain way. And for suppliers to understand that we are not the mainstream as a service, that we perhaps go to other solutions where we increase our asset base, because that we are not going to put our information, critical information, in public networks, in public clouds, because that's a risk. So understanding that is important for all suppliers who provide analysis, information analysis, analytics. So it's a question of finding each other in the middle.
Thank you then, and I leave the floor to Donatella.
Thank you very much, Davide. And I introduce now our next speaker, Zoltan Bartalis, who is going to explain to us how can Earth observation support energy resilience.
So, hello everyone, my name is Zoltan. I work for ESA, but not here in headquarters, but in Italy, near Rome, in Frascati. That's why we do a lot of the Earth observation stuff, and I think after such a great lead up to my presentation, I will not dwell too much on the background why energy is important, but I just want to tell you a little bit more about how we do Earth observation at ESA. You've heard quite a lot already that that everything that we talked so far yesterday and today is actually has very much to do with Earth observation. It's one of the biggest activities in ESA. Actually, it is the biggest by budget also for this year. It's about 1/3 of our total budget. And yes, for energy resilience, I think Earth observation is key. Observing any type of environmental information and processes. So we have this slide. You've probably seen it a lot. Most of you, some of you, you haven't. So just for the sake of the ones who are not familiar, these are our Earth observation missions from the past into the future, grouped along 3 bands. And we've been doing this for quite a while. Actually, the first missions that we did were for meteorology. And as you can see here on the right band, these missions are so mature, or they have become so mature in time, that we have outsourced them altogether to an agency called EUMETSAT, European Organization for the Exploitation of Meteorological Satellites. And I think it's really, as also Davide pointed out, it's really important to notice how the role that meteorology plays in many of the energy operations, because these things are critical. And detection of fast developing severe weather and weather forecasting is, of course, very important. So yes, here you can see the past and the upcoming mission types and names. The next thing is on the left band, you can see the science missions. These are purely scientific Earth observation missions which address cutting-edge Earth science questions. They are usually initiated by the scientific community, trying to get answers to very specific questions. One example is, for example, when scientists asked us, they begged us, so to speak, to try to monitor the extent and volume of ice coverage for climate change, and that's what we did. These missions, they have a lot of, like a huge variety of thematics and scope. They present a higher risk, and we try to get greater rewards by looking at really like the top-notch science getting out of this. This slide is a little bit outdated. Some of the missions have stopped in the meanwhile. Some others are, the launch dates maybe are slightly different, but it gives you a good idea about all the Earth science issues that we're trying to deal with. Yeah. So, and in the middle, as most of you know already, we have the workhorse of European Earth observation, the Copernicus mission, the Sentinels. This is really top. Also globally, it's probably the largest producer of Earth observation data in the world. I don't need to go into detail, but this is just an overview slide of these missions that we develop on behalf of and together with the European Commission. And these are the ones that are flying or are going to fly soon. Yeah, you've probably seen this, as I said, massive data amounts coming down on us, and these are also the basis of operational services run by the Commission. And by the way, the team in ESA that I'm part of, already starting in the late 90s, they have set up and tested all these Copernicus services together with the European academia and industry. So we've been doing this for quite a while, and I think that I'm really proud to work with such a group of people with such an expertise, and also the industry. Some of you are here today who are behind all these services. Right, and looking in the future, we also work on the Sentinel expansion missions. So this is like an add-on to the presently and to the default Sentinel series. They try to strengthen and diversify a little bit all the stuff that we can do with these series of satellites. And of course, we are also trying to take care of the continuity, so the resilience of the space assets. It's also a question of if we can ensure that satellites will be available. If something fails, we can launch new units. And these are called the Sentinel NG, the new generation of Sentinels. Right. Since we are here, I think I should also mention a few words briefly about our PHILAB powered satellites, because as you all know, there is a paradigm shift in Earth observation. We are also trying to look more into small sats and what these mean for the uptake and development of faster Earth observation services with shorter development times. And in this case, we talk about really missions that are transformational in terms of innovation. So it's like a step change in terms of how the competitiveness also of the European Earth observation industry will look like in the future. And right, I'm going to mention that just in a couple of moments also about the commercialization aspect. But just before that, just to give you a, I know this is a little bit too programmatic and you know, ESA internal stuff, but as you know, we work in cycles, in financing cycles. Every now and then our ministerial council gets together and tells us how much resources we have available. And what you should know is that the bulk of the Earth observation activities, so all this big research supporting the Earth Explorers mission's entire cycle, picking up the requirements from the scientific community, turning them into new sensor developments and mission specifications and design. This is all happening in that larger square rectangle future EO. And actually in my department, there's a subsection of this called EO Science for Society, where we bring together the science, the technology, and the applications. So everything that you know, new algorithms, new ways of working with data, strengthening industrial competitiveness also for pre-operational services, so not as much downstream as the colleagues here in the commercialization are doing. And training the next generation of scientists, workshops, cooperation also with international actors. This is all happening in Future EO. But I also want to mention, there you see there the climate space rectangle. That's a very important program that we have on observing the climate. So we have the so-called CCI, Climate Change Initiative, where again, working with the scientific community, we're trying to puzzle together long time series of data, irrespective of which satellites they come from, for the so-called environmental essential climate variables, ECV. So we've been doing that, we keep doing that, and I think it's very important also for the energy sector, because if we talk about energy resilience, well, resilience to what? Well, some of it is of course, the climate. So we need to know exactly what's going on with the climate. Also, I wanted to mention here the InCube program. As I said, this is in addition to what you heard yesterday from Geraldine about the overall commercialization opportunities in ESA. We have something very specific to Earth observation. It's called InCube. Now it's in its second installment, and yes, on this slide you can see the just yet another mechanism for industry to develop upstream and downstream Earth observation related products and services with a strong potential to become commercial. So there's also a co-financing element in this. So you're very welcome to take advantage of this as well. Right, and I cannot finish before talking also a little bit about this concept of the accelerators, the idea to broaden the impact of the use of space in society, and so also the use of Earth observation. The idea is that we should stop being mostly technical agency, lots of nerds and geeks trying to show data and algorithms, but also trying to convince society that it's worth investing in space data, space-based solutions, and Earth observation. And this was all agreed by the European heads of state in 2021. And now in ESA we are working on 3 of such accelerators, one on crisis response, one on planetary protection, and the third one, which is probably the most relevant for Earth observation, is on decarbonization of society to meet the climate goals, and that's the one that we call Space for a Green Future Accelerator. So we want to see this as a mechanism, as an enabler, as a catalyzer beyond the regular suspects working in the space sector, but also like working directly with stakeholders, trying to understand what exactly they need and match that up with whatever is possible from space and from non-space. And we consider that Earth observation is still in the beginning. We still haven't reached the full potential. We just want to make sure that it's not just pretty pictures and just opportunistic use of Earth observation, but a more structured and more strategic use of that, together with governments who are interested in this. And it's not, we understand that this is nothing that we own as ESA, and something that is meant to be partnered into a network of technologies, fully shared by everybody and funded anyway by public funds. Right, so one of the components of this green transitions, or space for green future, is the so-called green transition information factories, GTIF, and this is just a component to make sure that all the governments or all the stakeholders, the public, can access important information very easily without too much technical knowledge, just to provide actionable information and a transparent way of looking at data and combining different data sets to have quick and actionable insights. We are working on five of such GTIFs on 5 domains. One of them is energy transition, so that's very relevant for what we are here for. I just wanted to show you that we also had a precursor for the government of Austria, very advanced country in terms of green transition, so it was very suitable to have a short demonstrator for Austria. You can access it at that URL down there. And I'm just showing the parts of this interface. This is a platform-based, all of the GTIFs will be platform-based, online, in the cloud, trying to put together, as I said, various layers that can be used to address, to answer questions about, in terms of energy, for example, explore the trade-offs and conflicts for which areas can support what kind of use, site suitability, renewable energy expansion, and we've had that in Austria for solar and wind. Also combined with a lot of, I mean, this is basically just trying to give a nice tool to work with to people who are not experts, but who will have in a way a very transparent and fair way of working with all this information. So, and because I'm an engineer and I run projects in ESA, I just don't want to talk about high-level stuff, and I wanted to show you a few case studies, just like Davide was doing before with their projects. But first of all, in the past we were trying to understand what exactly is, how exactly can Earth observation support the energy-related scenarios, as we call them, and it's a lot of text, but I thought it was important just to show you the way that we think about it. It's, of course, energy resource mapping. This is the traditional way of, okay, satellites can help understand where is the solar potential, where is the wind density, and all of that. Snow cover, geothermal, biomass even, that we haven't even talked about. And then, interestingly, we also know more and more that energy demand characterization is extremely important, especially in the developing world. We work with, we have a dedicated program for working with the World Bank, Asian Development Bank, and all those international financing institutions. And when we approached them, we told them, well, you know, satellites can tell you where you can harvest all the renewables. And they say, well, you know, the governments that we are talking to and the ones that are coming for us, to us for funding, they already know pretty much where it is. Also because of us, because we have put together data sets globally and regionally showing the solar potential and all of that. But more importantly, we see that there is more and more interest in knowing where the demand is for energy. And that is a very complex issue. And a lot of countries, they have absolutely no idea where their people are who are in dire need of energy. There is no other way to get information on this in some countries just using Earth observation, which is a quick way of having at least a good first image of what's going on. Then there's, of course, production and transmission infrastructure site selection. We talked about that earlier today. Production and transmission infrastructure construction monitoring, a very interesting aspect that happens in real time with the use of satellites. Then creating inventories of existing energy infrastructure, so trying to map the assets and create information and intelligence about that. Managing the energy production operations, that's what I said about extreme weather, for example, how important that is, and the vulnerability, the resilience, the exposure to disaster risk, for example, floods, landslides, erosion, of the energy infrastructure itself. And now there's still a slide here to show you how various EO products and services fit into the main renewable types. It's, every time you think about this, you are slightly come up with different matches and pairings, but I think this is quite a good way of visualizing how the marine, wind, hydro, solar, biomass, and storage and electrification could benefit from the main types of Earth observation products and services there. Right, so just to illustrate resource assessment, we've had this before. This is something that you can see there, the IRENA logo, that's International Renewable Energy Agency. We've been working directly and indirectly through the World Bank, for example, through the SMAP program run by the World Bank, trying to create atlases, maps of the renewable potential for solar irradiance, wind on and offshore, biomass, and all of that, snow water equivalent, which is, I understand people here are quite active in the audience. Then again, to show you that we are working, just as I said before, we're working with the development banks, with the development sector. We have here IABG, who are working to support, in this case, the World Bank in Armenia, trying to address trying to get information about cloud cover to improve the solar potential data, and ultimately also mapping the roof potential for rooftop solar. This is a nice cooperation, I think. And also in the same consortium working now, we have, for example, the vulnerability of infrastructure to flooding. We combine various Earth observation and non-Earth observation data layers to get an overall vulnerability map, and we can actually follow how those power lines and power infrastructure is vulnerable to various risks, and categorize that. That is really important for some of these governments that we work with. And just a fun exercise, just before coming here, I was looking at offshore wind farm infrastructure construction here in France. This is the Fécamp offshore wind farm in Normandy. And I found that it's so easy to use, for example, synthetic aperture radar to try and observe how the construction has been advancing since early last year until last week, actually. And you can clearly see how all the operations took place, and how even at the end of this animation, you will see how the turbines have been mounted on those platforms, which give a lot more backscatter, so the brighter points become visible. Just a fun thing. And also, I don't know if you noticed, also the coastline is varying because of the tides, and even the response of the backscatter of those turbines is varying because of the tidal changes. So that's also another thing that is important when you're planning the grid connections to the shore. And to close, just another project that we are running to show you how advanced object detection machine learning methods can be used on free and open data from Sentinels in this case, to fully automatically detect at least parts or most of the infrastructure, in this case the wind turbines globally. Quite an amazing result, actually, because much of the assets are actually not known in various countries. So that's just a teaser, just some nice pictures to look at, but the message is that yes, we are here to listen to you, and we have various opportunities for industry and academia, and we want to cooperate as much as possible. Also inside ESA, I think it's sometimes quite difficult for externals to understand who is doing what in ESA. There are some overlaps. We're trying to work on that, and I think we will ultimately try to figure out better how to do things. And meanwhile, please talk to us. We have plenty of ideas, or we listen to your ideas, and we'll try to create opportunities for you. Yeah, that's it. Thanks very much.
And we have the time for one question.
Thank you so much for beautifully demonstrating what can we do with the Earth observation data when it's open and free to access, especially for researcher. So my question is that, is there any program or plan in ESA to make some mandate for private company that provide high resolution commercial optical and especially SAR data to the research and academia? And I can see that it's with my academic hat because I'm a professor in a Western Norway university. But as a scientist in a StormGeo where we are developing also a products for Earth observations, the very first problem for the high resolution, which are very useful for industry, is that when it's come to scalability, they are so expensive and it's so hard even to show a pilot project to demonstrate what can we do with a high resolution SAR, high resolution optical, or thermal, so on and so forth. So since this commercial company, at the beginning, start to have some kind of governmental support, some taxpayer monies to develop the technology, do you think ESA can put at least some mandates on them to make this kind of high quality data also partly available to for R&D purposes?
Yes, for that we have actually mechanisms in place where some of the high resolution data providers or the commercial data providers, they share a specific quota with ESA so that it can be used in R&D activities. It's called the ESA third-party mission scheme. You can, as a PI, come with a research idea, and there are always ways to get at least some data for demonstration purposes. And that's fine also with the operators. They're also interested in showcasing their data. And actually also in Copernicus, we have the CCM, the Copernicus contributing missions. Many of them are commercial, and you would be able to partner with this through our colleagues and make data available through that. So I think as long as it's research, it's a very nice way, but then if it's about commercialization, and that's what we are here for today, you would really need to think, okay, is this scalable? As you said, it could explode the price of a service. So as long as you manage the expectations of the users, you can demonstrate it, it's not a problem, but in the long term, I think there should be, yes, as you say, there should be a mandate, and ESA usually is not the one who has the mandate to operate such services, so we focus more on demonstrating and enhancing the uptake with the stakeholders.
Thank you very much, Zoltan. And I invite everyone for a 25 minutes break, and we expect everyone to come back by 11:30. Thank you. Yes, exactly. It's on the. Yeah, it will be great. Ça, c'est. Non, Federico, il va envoyer un mail après. Et justement, les gens qui sont pas au courant, il y en a un qui proteste. Et là, il y a une transition. Alors, avant la fin, je pense. Ouais. Alors maintenant, start up pitches, ouais. Et les autres peuvent venir sur le site.
So welcome back from the break. Before starting the startup pitches, I would like to call on stage with me the startup who are going to pitch. So we have Max Aragon, CEO and co-founder of Thematics, Andreas Salentinik, CEO and founder of Ubicube GmbH, Lucas Brenner, CEO and founder of Energy Family, and Andrea Gulisano, CEO and founder of MESPEC. If you could come here, and then it's time for you for your pitches. And we will have time for 1 or 2 questions after each pitch. So the first one is Max, and then I let you go.
Right, thanks for the introduction. My name is Max Aragon. I'm representing Thermatics. And here I'm coming to talk about the topic of the heat green transition. Specifically, we're working on what we called urban thermal digital twins. And just to give you an overview of who we are an Austrian-based startup from Salzburg. And we all graduated from the Copernicus Masters in Digital Earth at the University of Salzburg. And here I like to acknowledge ESA for enabling the internationalization, because our team is mainly composed from non-Europeans. And we're specifically on a mission to enable serial building renovation. And this is because there is an interesting opportunity coming from the European Commission, specifically the Energy Performance of Buildings Directive, in which the EU member states need to identify the worst thermally performing buildings. And at the same time, there is the availability of new space satellites, specifically AuroraTech, Constellar, and Satellite View, as you saw yesterday. But even more, the cost of the thermography sensors has also decreased, and there is a chance to use them at scale. At the same time, there are initiatives like Destination Earth for the development of digital twin platforms. So this is what we're working on. The project was previously named Thermopolis, now it's called Thermal City. And we are proposing what is known as an ultra-high definition thermal mapping. Of course, we are aiming to use Earth observation, but to date, there is no available very high resolution thermal imagery. So we're now working with aircrafts. And we're not only mapping rooftops, but also we're mapping facades. So we're driving vehicles with thermal cameras to really get a full 3D representation of the built-up area, specifically for applications in summer and winter, like urban heat island detection, renovation potential maps, renovation verification, as well as district heating anomalies. This is the progress thus far. We started in December of 2022 as part of a Space for Energy hackathon organized in Austria. We then received support from angel investors. We became part of the ESA Big Austria, and we also became part of the Startup Salzburg Incubation Program. Then we received the prize for the Cassini Idea Challenge. We received some grants from Austria for the development of a pilot demonstration, a city-scale pilot demonstration of 3D thermal maps. And we aim to secure the IP and launch the startup officially next year to really kickstart commercial operations at the EU scale by 2026. So because we're in a commercialization event, I like to just showcase what are the current costs in case you are part of a city or a municipality that requires this type of services. We can offer the surveying, the 3D generation of the building at this price. Of course, this is really the most affordable price that you can find at the moment because it's what we're starting now. We also aim to provide the monitoring services, so the update of these maps, as well as the planning and the what-if scenarios for urban management purposes. And for investors, we want to create more pilots, more demonstrations, so feel free to reach me out. Thank you so much.
We have the time for one question for Max.
Hi, my name is Guillaume. I'm from ArcSpace. Thank you and congratulations for the road so far. You mentioned that you were lacking very high resolution thermal. What is the current capability now, and what are you looking for in the future? And is that a problem for scaling of your activities?
Yeah, thanks. So the first very high resolution thermal satellite was launched by Satellite View this year in the summer, last year the summer, with resolutions of 3.5 meters per pixel. This is important because it enables the assessment of building a specific heat losses at the rooftop scale. And because it was the first one, it was really experimental, and now we're moving towards new constellations. So Satellite View is not the only company, it's the first one, but there are also other companies coming into the segment. So some estimations that I've done is that by 2030, there will be around 200 of these small satellites providing infrared thermography, high resolution imagery. And yes, now we're working with aircraft because that's what's available. But of course, we will integrate the new space satellites as soon as they are available. Thanks.
All right, so hi everyone, my name is Andreas Salentinik and I'm the founder of Ubicube, Austria-based Earth observation startup. And at UbiCube, our mission is to leverage space data to boost your business, to boost businesses of any size. And we are doing that. We are delivering services based on EO data for the real estate industry, but also recently we started looking into the energy field as well. Because as you all know, the energy sector is facing multiple challenges at the same time. Decarbonization, decentralization, and we are especially, we can deliver value in terms of digitalization. So we are helping companies to digitize processes and to improve efficiency. So how do we do that? We basically use all kinds of geodata, so all kinds of different satellite imagery with different spatial resolutions, with different sensor types, so starting from SAR, optical, and we put it together with already existing georeferenced data sets, and we feed all that data into our Geo AI environment, where we have specific algorithms that are trained for monitoring, and we really focus on the built environment. So we are monitoring the built environment, keeping track of where new buildings pop up, where buildings are demolished. We do that in an operational setting already. And then on top of that, we can use high resolution data to extract like individual features of properties, like building footprints or swimming pools. And the whole thing really becomes powerful when you combine it with existing data sets. We discussed that yesterday. Also, in my opinion, EO is a nice add-on to existing data. And we always try, of course, to make this information or the insights available at the very low level in terms of we don't need like geoinformatics masters to use our services. Anyone should be able to do that. And I prepared like 2 examples what we are doing in terms of energy resilience. So in order to be to have a resilient grid, you have to have good data, right? So companies are putting a lot of effort in keeping their data updated. And here, the example on the left side is about building data. So where are the buildings? Where are the new buildings? Companies, grid operators need to do that for energy planning, also for construction work and so on, for a lot of different things. So how they do that so far is sending people to the field, walking around looking for new buildings, and then digitizing that. So we developed a methodology or a service where we basically help them planning and doing their surveying trips. And with that, they can increase, or decrease actually the update cycle from 7 years to 1 year. That's really a massive boost in efficiency. And the second example is about climate resilience and vulnerability. So we talked, of course, to a lot of grid operators, and they're all facing the same problem. Okay, we need to do something about that. We also they have to do that also in terms of, because of the EU taxonomy and the ESG regulations. But they start from scratch, and they have issues even, collecting the necessary data. So that's why we designed this service. We are providing an interface where you can get all the necessary information, climate data, weather data, climate projections, land cover data, land cover change, in order to assess the grid in terms of climate resilience. So those were just 2 examples. Over the years, we were able to, create a network of customers, of development partners, and we were also able to win 2 hackathons organized by the Austrian Climate Change Ministry. And this was really valuable for us because with these hackathons, we had the possibility to get in touch with the grid operators, for instance, and everyone is leaving the bubble, and you come together and discuss what can we do to get value together. And so this was really interesting. And this was an event similar to this one here, so I just wanted to highlight, because yesterday there was the discussion, how can we raise awareness, how can we develop new solutions?
if you also want, you know, if this resonates with what you're doing in your daily business, I'm of course more than open to discuss potential solutions. Please don't hesitate to contact me. I'll be here. Or also you can of course send me an email or add me on LinkedIn. Thanks a lot.
A question for Andreas.
Hello, my name is Lucas. I'm the founder of Energy Family, and we have the vision to democratize energy systems. During the last years, every one of you could see how dependent we are on international energy markets. And there are only a few players who can determine energy prices for whole countries, but also for the whole European Union. Therefore, the EU decided to create new rules for the energy markets. And now there are EU directives in place which makes that possible to sell electricity from one individual directly to others within energy communities. And in energy communities, you can produce, store, and sell electricity to others, other companies, municipalities, or other private households. And why do we do that, or why does the EU want to do that? So that we are less dependent on a few players, and we democratize the whole system. And in order to get more fair and stable energy prices for all of us. We as Energy Family provide a platform as a service solution where everyone can register and easily sell self-produced electricity to others. One of the biggest unsolved problems in renewable energy is that the production and the consumption curves does not fit together perfectly. And therefore, we are now in a Horizon project where we use satellite data in order to predict the production of solar power together with other big institutions in order to realize a distributed energy management system. And this we're offering to energy communities, cities, regions, but also to network operators. How does that work? So we are predicting, based off weather data, how much energy will be produced in every single site of the production. And with the knowledge of the whole energy production of the community and the knowledge of how much is produced, consumed, then we can control different electrical loads. For example, the charging of electric vehicles or heat pumps or other electric devices. Yeah, we have the plan to make this service available for all European citizens to an affordable price, and we want to increase the efficiency of electricity and renewable energies. Yeah, what we are looking for sales partners all over Europe. We are looking for research corporations as well as investors. Yeah, if you are interested in that topic, please get in contact with me. I would love to discuss that further with you. Thank you.
Nice presentation. Did you have the opportunity to ask some Ukrainian people, because currently they are facing some troubles in their networks, and they are already trying to gather, and they are already succeeding to gather their needs in small cities and so on. So maybe you can have some lesson learned from that and from some use cases, interesting use cases.
I'm sorry, could you repeat it?
Ukraine, currently in Ukraine, They are already doing things like this, but without the type of tools that you are proposing. So maybe you have some potential partners and customers there. Did you check?
We did not check yet in that country, but yeah, we now built a system in Austria where these directives are already in place and transformed to national laws. And in Austria, there's a really boom of energy communities. During the last year, there grow a lot of communities, and also other countries will follow.
Good morning. Thanks to the ESA team for giving me this opportunity to present MESPAC, where we're trying to unlock the full potential of satellite application to the offshore renewable energy sector. Over the past 15 years, my team and I have been struggling in collecting data of wind, waves, and other metocean variables offshore. We interviewed approximately 60 potential users of MESPAC, and 3 main problems emerged. First of all, when you start an offshore in situ data collection with physical instruments, it can take a lot of time, even 3 to 4 years. Second, when you have offshore wind farm up and running, we interviewed one of the metocean experts of a major offshore wind developer company, and they told us that 50% of the time, metocean data coming from the SCADA systems are wrong. Others interviewees told us every time, by the way. The third problem is that offshore wind farms span on huge areas, even 400, 500 square kilometers. Think, an average offshore wind farm generates revenues every year approximately of 250 million. So what if we can improve the energy generated by just 1%? Or what if we can accelerate the development process by, let's say, 1 year? Our solution combines data coming from satellite sources, in situ data collection systems, and we can also intake data coming directly from the users. And we feed all this data into our probabilistic supervised gap filling algorithms that are trained to target the same level of accuracy of in situ measurement. So we can provide reconstructed time series of the metocean variables of interest. We can accelerate the process through which metocean surveys are collected by 50%. And we can also provide near real-time nowcast and forecast data. But let me give you an example of our patent-pending solution. This is a site in the North Sea, where we have an instrument that collects data of wind. For example, this is the month of February 2021. There you can see data coming from satellite, and if we look only to this last data set, this is what we're left with. So we're losing a lot of information. If we apply our algorithms, we can reconstruct the time series, which is a very good approximation of the real time series. We were able to reach 97.5% accuracy. The market for offshore metocean survey targeting offshore renewable application is worth 4 billion. A competing solution are physics-based modeling techniques, but they take a lot of time for customization, and they consistently underestimate extreme events. On the other side, you have in situ metocean survey companies that we look at them more as potential partners for our solution. We aim to provide our solution to the customers a data and analytics as a service approach, also through API, of course. And we aim to serve them throughout the whole lifetime of a project, which arrives to be 20-25 years. As a team, we have a pretty thorough experience in the sector. We feature a pretty strong domain expertise in offshore renewable energy. MESPAC was born thanks to the support of the European Space Agency. We changed the logo, by the way, recently. During our TechX Accelerator program, we raised the pre-seed round. We're now raising a seed round and also starting to collaborate with the first pilot user to demonstrate our solution. So I hope some one of you can be interested in what we are doing at MESPEC, so just please, let's get in touch. Thanks for your attention.
Any comment or questions?
Thank you.
So it's time now for the roundtable discussion on energy resilience. I would like to call on the stage the moderator who is going to introduce the speakers. So Maria Zaretskaya, who is Business Application and Partnership Officer at ESA. Maria, if you could join.
Thank you, Donatella. So please, let's give a warm welcome to the stage to Oscar Del Castillo, who is a technical project manager and lead architect for ELIA. Then please Sven Prizavara, co-founder and co-CEO of Live.io. Marion Mesador, who is product manager at Kairos. Wojciech Walniczek, partner at OTB Venture Capital. And also Ian Llewellyn, who is head of energy engineering at UK Department for Energy Security and Net Zero. So welcome. So good afternoon. Thank you very much for being here. So the theme of the panel, we're going to talk about energy resilience. We've had a great introduction to energy resilience today, the definition of energy resilience and all the various applications. So we saw the definition is the ability of an energy system to survive and also recover from failure or adversity. So maybe I'd like to start with kind of an in-depth introduction of the panel. So maybe Sven, I will start with you. So please can you tell us how does Live.io contribute to enhancing energy resilience, and maybe share a little bit of the success stories and the challenges that you're facing. And do you have microphones? So can we have a few microphones, please?
Thanks. Yeah, first of all, thanks for having me. Very happy to be here today. And thanks for the boat ride yesterday. It was fun. So exactly, I'm Sven. I'm one of two founders at Live.io. Live.io is an Earth observation analytics company of now 110 people. What we do is we unlock the full potential of Earth observation data. That's our goal. And we have two products in the energy space, which in my point of view exactly help to make the energy networks within Europe and the world more resilient. We have one product which is in the field of maintenance of electrical overhead lines. So we do vegetation management, or our solution allows grid operators like ELIA or others, like ELIA, not ELIA, not yet, but maybe in the future, to monitor vegetation next to the overhead lines and to prevent that due to, for example, more extreme weather events, trees would fall into an overhead line and would cause a power outage, or, for example, especially in southern Europe, would cause a wildfire. That's number one. And number two is our product in the pipeline space. We help to prevent pipeline leakages due to either illegal tapping or construction sites, and help to prevent that there's an interruption of any kind of flow which is going through these pipelines. So these are our two products, and right now they are being used by grid operators on every continent of the globe, and we hope that through that we can do our part in making the energy networks more resilient.
Thanks very much. So maybe Oscar, if I go to you next. So can you please tell us what you do at ELIA and give us maybe a little bit of a taster of what you're going to talk about later on how you're already using space data.
So in the introductions by Alfonso and Davide, we have learned about how relevant critical infrastructure grid operators are in society. So without transmission there is no distribution, and there is no power. So I work with earlier in a group that we work towards the blackout mitigation program. And in that blackout mitigation program, what we have decided is to deploy a private satellite network to secure the resilience, to be able to assess information about our assets in any circumstance. Circumstance that if we have a blackout, as David informed before, we cannot rely on public telecom infrastructure. So then we need our own private infrastructure to reach to our data, and also to send for recovery, to send our field technicians to recover the network. We need to communicate with them. And we assume that during a crisis, there will be no other means to communicate but satellite. Then what challenges we find when we try to approach the market to get solutions is that SLAs are not compliant with our security and resilience standards. So what we are doing since more than 10 years now is to try to get from the market the type of solutions we need. And it is not been an easy path, and we are facing a number of issues with finding the right solutions. Now, I think that I answered the question, or
yeah, for now it's good. Well, we can come back to this.
Two main fields. Yeah. Secure connectivity is the main one, and the other one is that, as Sven introduced, we are exploring Earth observation for asset management and to prevent the worst effects of crisis, meteorological. So in that sense, our colleagues from innovation are exploring LiveEO and other suppliers of these services.
Thanks very much. So Mario, I go to you next. So you work at Kairos. Kairos got a lot of publicity, I think, in the last years. You're helping us to keep accountable some of the worst global polluters. So can you share with us some of your biggest success stories and maybe some of the challenges you're facing at the moment?
Sure. Thank you for having me first, and nice to meet you all. So yes, Kairos is a French company founded 8 years ago now. We have different missions focused on bringing data to help decision makers change their impact on the environment. There's a big mission that is focused on energy transition. And that's also where we've seen the biggest successes over the recent years indeed. We have a product that we've developed, I think it was 3 years ago now, on detecting super emissions of methane. Most of them, the human-related ones, they come from oil and gas production and transportation, and they've come largely unnoticed because they happen in remote areas. Methane is a gas that you can't see with your eyes. There's no smell, there's nothing. So it's really easy to underreport. And our mission has been, on all the topics and on methane especially, bringing transparency so that people can act, especially regulators. The biggest challenge we faced at the beginning was that we went with that information to operators, saying, now that you know, you can probably fix it. And as it turns out, people are not really happy to know they are big polluters. And so we had to go to other people, regulators a lot, the press, NGOs, the rest of the world who actually cared, and it made things change. So one of the biggest successes we recently had, last year we made a big story on Turkmenistan, with probably the worst emitters in the world in terms of super emissions of methane. And we shared a story with The Guardian. The Guardian said that what we had measured as per methane emissions over Turkmenistan was twice the emission of the UK annually. And those are things that we can fix. And so after that story, the US stepped in and built a deal, an agreement with Turkmenistan, where they are funding mitigation efforts and providing technical support so that those things can be fixed quite quickly. And second big story, same approach in Kazakhstan. We've been revealing a leak that lasted for 200 days after the blowout of a well in the country. And because we, again, worked with Bloomberg News, it became known by the larger public. and they finally fixed the leak. And now we see the global methane pledge coming from the UN, so there's a majority of countries acting on that topic, which when we started was nowhere on the agenda. So I think it's really a demonstration of how transparency can really accelerate things on a specific topic that has been unknown, because what you cannot measure, you cannot act on.
Thank you, and I think that's a fantastic example of how space technology is really driving change and helping us with the green transition, and thank you very much for that. Wojciech, can you please tell me a little bit about OTB VC and what kind of companies you support and what kind of space tech you look at?
Hello, I'm Wojtek, I'm from OTB Ventures, and we are a deep tech fund, pan-European deep tech fund with one focus on space tech. We've been investing since 2017, and we've been lucky to invest in companies like ESA, like Hygrosat, SpaceNow. So we deal with both Earth observation, constellations, downstream, upstream, in-space infrastructure. So we're looking at pretty much all the angles, let's say everything that serves the Earth. So we're probably not yet in the deep space exploration, lunar exploration, but anything that serves the Earth, including energy sector. But we don't look at specific solutions for like specific markets long term. So what we look at is solutions that can serve many markets, even if at the very beginning those solutions are targeting specific markets, because you need to focus on something. But one thing I wanted to take a note of is like we in this room are passionate about space. So we have a group of people passionate about space data, space infrastructure, and I'm sad to break it to all of us. Clients don't care about space. I mean, they don't care about where the data comes from. They don't care about whether it's a fantastic satellite technology, whatever. Clients and one of our representatives of potential clients is here, and I'm glad that we have somebody from the client side because we need to work with them. They care about their problems. They care about solutions. They care about solving to simplistically either more revenue or less costs. And whether that comes from space, they couldn't care less, I guess. And what we love the most about companies that come to us is companies who don't come from this technical perspective, oh, we have this fantastic technology to solve something. We need somebody who says, like, we talk to clients, we think these are the problems, and these are big problems, and we think space can be critical at solving those ones. And these are the best discussions we usually have at the very beginning. And the innovation that all those people gathered here, I'm really amazed at all the innovation coming from the technical side. But and we heard a fantastic example of something that I'm seeking for is business model and go-to-market innovation. So where we see the most spectacular cases of successes is where somebody came with a nice, let's say, technically complicated or innovative solution, but actually married that with a go-to-market innovation strategy. In this particular example, we heard, you go to one side of the market, they don't want to listen because there are some perverse incentives, let's say. So you go to the other way around, and discovering this process, how to get to the client and how to iterate the business model. Very often we hear like the business model is either we're going to sell a satellite itself, license the satellite, we're going to sell data, or we're going to sell applications. Why? I mean, that's the typical way to do it. Why don't we hear more innovation around business models? How do we monetize the data? How do we monetize the applications? How do we tie that into workflows of clients? Clients, and especially the big ones, are used to doing things. And if you come and break everything around, it's going to be hard to sell to those people. How do we tie into their workflows? How do we make the space data invisible? Like the biggest probably space data case these days is GPS or GNSS data, and we don't see that. Nobody sees that. Nobody thinks about Uber application as a space application, but it's inherently using space data. So how do we make this data invisible for clients and at the same time charge them where it's most valuable and that's least risky? So I'm urging everyone, and I'm saying from experience, the best discussions we have, if there's a combination of new innovative technology married with a great business model innovation and GTM or go-to-market innovation. So I urge everyone and would love to have more discussions around kind of this merit innovation.
Just curious, could you give an example of an innovative business model that you think has worked really well and maybe surprised you in its innovation?
Well, you know, the classical case of such is, I know, Facebook and Google. I'm going to go to space. But, you know, back in the day, I don't know, many people probably remember, in 2012 when Facebook was entering public markets, nobody knew how they're going to make money. It was for free. It's still a free application. And then it was a whole stream of companies who figured out, I mean, now it's obvious. But 20 years ago, it wasn't obvious. Let's monetize through advertising. I'm not saying, you know, we should monetize data through advertising, but at the same time, why not? Maybe there's some, you know, innovation here around advertising. Our company, Hydrosat, is actually working with potential providers. So they provide thermal data, maybe not as it's not like super high resolution thermal data, because it's adjusted not for building or cities. It's more like agricultural level thermal and infrared data. They're working with trying to partner with manufacturers of irrigation hardware. Right, the premise being that all those people already have access to irrigation markets, and one of the use cases they're working on is like how to increase efficiency of irrigation. So they all have access to those clients. Their problem, though, is selling hardware. It's a you know, not highly growing business. So the client is thinking, how our client or partner in this case, how can we increase our revenue through implementation of smart solutions to our hardware? And it's not a deal done, it's still a long way, but it's an example of innovation of how you work with a partner who's selling hardware to whom you can provide the specific data to build value creation that's eventually going to be a value creation also for the end clients of those infrastructure or those providers of equipment, to implement the data, and the end client won't even know there's a space data included in this one. So this level of combining partnership with value chain partners of your kind of market to implement new sets of value that eventually will create something new for the client is really something I'm seeking.
No, thanks very much. So Ian, I come to you. So you're the head of energy engineering at UK Department for Energy Security and Net Zero. Can you tell us a little bit about how energy security is part of your policies and the kind of innovation that you're working on?
Energy security is the #1 priority for most governments. You don't get re-elected if you just let the electricity network go down. So everyone is really keen on electricity resilience. And we live in a time of change. I think there's a Chinese curse, may you live in interesting times, and that's where we are. For the last 100 years, if you wanted a resilient energy system, you simply had fossil fuel power stations, and if you wanted more power, you just put more coal in. If you want less power, you took less coal out. You can't do that now because we're trying to decarbonize, and so a lot of the controls that the electricity system operators have been using traditionally, they no longer have. And this is where I think smart solutions of space come in. And I've spoken to a lot of people at this event. It's quite amazing the ideas that are coming out of the space community. And I think a lot of them are going to be very valuable as we go forward. But the usual complaint I get is, you know, it's very difficult to get people interested. It's quite difficult to turn around traditional ways of doing things in the energy industry. And that is probably what you would expect, considering they've had 100 years of doing things a different way. It's not that they don't actually recognize they've got to change, but change takes time. And from a government perspective, we spend a lot of our time just trying to get the electricity industry and other energy industries to change their behavior and to incorporate new ideas into their day-to-day working. It's a challenge, but I think if you come back in 25 years' time, I can imagine that we're going to see the space industry and the energy industry is quite tightly integrated.
And what's in your pipeline? What what are you working on?
As part of my job, we fund what we call disruptive technologies. So the UK government has a grant pot which we give small companies mainly, but also some large ones, money in order to develop new ideas. One of the things we're looking at is space-based solar power. So the Solaris concept, which we heard about yesterday, we think that could be very important. It can compete with other technologies that we can give baseline power, such as nuclear fusion. But it has the same problems as nuclear fusion. It's going to be really expensive to develop. It's probably not something that any one country can do on their own. We need an international consortium to do it. And it's going to take time to set up and approve. And one thing we have learned over the last 10 years in developing renewable technologies is that investors will only take a certain amount of risk. So they will take technology risk, but if they take technology risk, they don't want any investment risk. So they need guaranteed returns on their investment. Right now, with space-based solar power, there is not the regulatory environment, and there's not the guaranteed revenues that you'll get, for example, if you're an offshore wind developer. So it's quite tricky, but we see this as quite a promising technology.
Thanks very much. And so you mentioned how conservative the energy industry can be. So I would like to grab onto this and go to you, Oscar. So maybe can you tell us a little bit more how space technologies can help TSOs to ensure the Green Deal, strategic autonomy targets are reached, and if you agree that there is a lot of conservatism with the energy players?
Yes, definitely. There are, by VC, we have I'm happy to hear you saying about business models and about, for us, we are a community of TSOs. We are not competitors to each other in Europe. We are co-creators. So the business model of platform and the co-creation between an ecosystem of suppliers, different TSOs, regulators, is critical. And if we put an example of an opportunity that we pick now in TSOs is the Green Deal is based in several pillars, and one of them is Repower EU. Repower EU is demanding the massive integration of renewables into the energy mix. That means massive investment in infrastructure, transmission, to bring power from the sea, the wind power from the sea into the continent, the sun from the south into the continent. And that means interconnections between TSOs. The more the interconnections, the more the need for data. And as Ian explained, the complexity of the system grows. There is no potentiometer to increase power or reduce power anymore. We have a diverse ecosystem of energy sources. And to tackle that, to make the most of, we need an overall system view. We need a system of systems view. And in our perception, and that's where we see the opportunity for this community, is that we need a platform that can enable trust for the exchange of data. So far, if we are going to the public cloud with critical data of our assets, we are risking our security. So we have seen that energy security is priority for governments. So what we need is a platform that enables not only the secure connectivity and exchange of data, but also that is resilient and enables more functionality for TSOs. We have a lot of examples through the different pitches here of what type of space data can be integrated in a TSO platform or an energy grid platform that can secure both data to improve operations, asset management, prevent, to help balancing the network, to know where the energy is needed. So all of that data is there. What we need is to harness that data, bring it down, and put it in a reliable, trusted platform for TSOs. And that's what we are working on.
And Sven, you work a lot with energy utilities. So what do you think needs to be done to make them more receptive and more open, less conservative to new solutions?
I mean, I think like what I would say is I think that the energy industry is changing right now a lot, and I think that just like considering all the different kind of things which the energy industry, all the TSOs and DSOs worldwide have to deal with, from electrification of the network to decarbonization and whatnot, and digitalization at large is quite a heavy task for utilities. But I see a cultural change within utilities happening. It's taking time. It's slow. But what can we do as an outside company to do so? Education, and I think this is also where ESA can play a role in, as many other stakeholders, educating the TSOs and DSOs and grid operators globally about that. Then on the other side, obviously, companies like ourselves need to be able to provide the service to end customers, which is really like a turnkey solution, because ultimately offering a solution which is, hey, here's another satellite data set, look at it, do something with it, and then the customer will tell you, cool, I will look at it exactly once, and then I don't have anyone who should do that. So really building a solution which is a turnkey solution for the end user is super important. But then I think like it's important to also find the right middle ground, because between like the rightful demands of a grid operator and reality, right? Because there are a lot of security demands to what like a supplier to a grid operator needs to comply with, and is all good, like SOC 2 compliance. I think that's something one should have if working with a grid operator. But then there's obviously, can I process 1 petabyte with H100 NVIDIA CPUs on the utilities cloud? No, likely not, because the way in which technology is advancing is at such a rapid scale that everything you would try, like any kind of innovation, would lag behind 5 to 10 years behind what's currently working. And I think the energy transition can't have a delay of 5 to 10 years to what kind of technologies are used in other parts of the society. So I think it's important that you find a good middle ground between innovation and rightful conservatism.
No, great advice, I think. No, thanks very much. So I'd like to talk a little bit more about investment and market trends, and also grabbing to the comment that Ian said that, you know, who should fund this this investment. So maybe as a first question to you, Wojtek, can you tell us a little bit about the current landscape of investments in space tech, especially related to energy? So what kind of trends you're seeing, or any shifts?
The general global, let's say, trend in space tech, unfortunately, is quite negative, because we see flows of capital, specifically private capital, into the market decreasing. Now, that's true for the last 2-3 years, but let's remember we're also coming off a tremendously hot 2021, 2022, where things were just, you know, insane. So I hope we're going to stop. I mean, the flow will stop at the level of, let's say, longer-term trend, so that we'll see a peak, and then maybe, you know, we'll see a longer term trend. But the data so far shows that it's actually coming down, which at the end of the day I'm not seeing as a negative. You know, we've seen a lot of so-called travelers, or like tourists into the market. You know, people who really didn't know what they're doing. Now it's a devoted market. Like whoever is staying is really devoted and a true believer.
So is that the reason why it's going down?
Yes, one of the reasons is I mean, we've had funds or institutions that came, or, you know, family offices who came into every market. By the way, 2021 is just crazy. Like whatever you look at, whichever area, that's not only space, every area of investments, you know, starting from AI, crypto, and so on, there's like peak, and there is a fall. But many markets that are already finding its throw and starting growing, it shows that long term, actually, the median or the trend is actually kept. And I really hope this is also going to be the case for space tech. And that's speaking of, let's say, equity financing from VC funds. We see more and more interest in later stage financing by private equities. And we had OHB being taken over financed by KKR, and that's also included RFA, who received part of the financing from them. We've seen Maxar being taken over. So there's a bigger set of capital that's out there. We still miss the kind of middle ground, I would say. There's still a lacking funding gap between, say, A, B, to later stage round where the PEs maybe can take over, or maybe we can IPO. By the way, IPO market is also horrible these days in general, but also specifically for space tech because of the so-called SPACs craze, which burned a lot of people, and many of most of the companies, space tech companies who went public through SPACs these days are either, many are bankrupt, but some are very much at the bottom. Some are keeping up, but the IPO market is also really tough. So this kind of middle ground is being filled up, and I see green shoots, let's say, of more funds, bigger funds engaging into this area, and also the qualitative discussions we have with bigger funds are such that they're hopefully coming back to the market. Speaking of that, it's not the only level of financing. We have other instruments like venture debt, and specifically for energy. When I think about it, we'll have to engage other players in the market than venture funds, like project finance. Yes, many of the projects, because they're going to be large capex, they will require quite some heavy financing from traditional players, part of which space tech is going to provide solutions for. It's not going to be only for space tech, but I think we should start engaging as a community with more project finance people, with PPP people. And I was actually here in this room couple months back, where I think it was ESPI who was organizing this workshop around various other financing schemes we can employ to bring space to industry, not only energy. It's a problem across many industries. Energy probably being the more conservative, slightly maybe slower moving market, but at the same time, I think it's a huge opportunity. If somebody cracks the problem, it's going to be a huge opportunity there. But we need to start bringing in. I believe in private capitals. Public capital is good, but it's good as long it is. But private capital from those various sources like project finance, PPP, normal debt, asset financing, and so on and so forth, which we don't see yet coming. So it's a very complicated, I would say, financing picture that we still need to start building, and it's still not there. But at least there is some work being done on that. On the trends, I see yesterday and today, I pretty much heard everything being said about any innovation that I've seen so far in the energy sector, right? So we've discussed the vegetation monitoring, solar space, like it's been mentioned in this room, everything that I seen in the market. But very few of those ideas are already with the commercial clients who are willing to accept those. And not even mass scale. It's not there yet. So I can't say I see a one particular trend or a couple of trends that are picking up in terms of energy space usage for energy market. There's a lot of bets. It's like Chinese let 1,000 flowers blossom. So I can see 1,000 flowers. I can't yet see something that I'll say, okay, that's going to be the first market to move to.
And in terms of risk taking, how open are you to risk? Are you risking it on not just technological risk, but also commercial risks, like Ian mentioned?
So it depends on which stage the given investor is investing. We mostly invest at Series A, which is more typical for us to bet on the commercial risk rather than technological risk. At Series A, we want to have a solution that's technologically proven, and there's definitely no scientific question around the solution. Hopefully there's no engineering question. Obviously the solution needs to build up and so on, but there's no technical question. Commercially though, yeah, there's a lot of questions. So we are betting on this type of, let's say, mostly risk, but there are earlier investors, pre-seed and seed, who are betting on technology, and their risk appetite is pretty much bigger on the technical or even scientific side, more than I am. And again, we're a little bit lacking the ones who, so I can do, let's say, take the risk of early commercialization, and a lot of my work is around figuring out what this technology can be used for, what's the business model, what's the GTM, how to approach the clients, how to get first clients, how to get to, let's say, 2, 3, 4 million of revenue. And they should be more investors who are willing to take the risk, to bringing to 100 to 1 billion revenue. It's we've seen them. We don't see them that much, but again, the green shoots are that they might be coming, because we as a Series A fund, and we cooperate pretty much with everyone in the market. We can't carry the company to say billion revenue. It's just impossible. We just don't have enough means, enough capital in our funds to finance the companies to 1 billion. We've seen situations of hundreds financing to hundreds of millions, but again, we need somebody, and that can be a creative set of financing, not only equity but through debt. Again, I won't mention that again, to come in and help us carry the company, to 1 billion revenue. But it's still something that that we're not seeing en masse yet.
No, thank you. And Ian, we'll be interested to hear your opinion. Would you agree with everything?
Yeah, I think I would. What I would say is that in the energy business, 1 billion is not a lot of money, I'm afraid. For example, a nuclear power station, we're building 2 in the UK, they're 25 billion each. So when you're looking at putting space into these applications, you are dealing with people that are used to project finance. And you have to make sure that you have got they know that your technology works. Yeah. They also know that they use their technology. They're not going to be putting a lot of their capital at risk. I think it's horses for courses, and you really have to work as an SME in order to impress these sort of people. The good news is that 10 years ago, really renewable technology and green technology was a European thing. Now it isn't. The Chinese are investing lots and lots of money and are always looking for technical solutions. The Americans are investing lots of money. So you've got a much bigger market than you would have had, say, 10 years ago, where everything was much smaller and largely concentrated in Europe. So, if you're an SME in this space, you're kind of, in the right space to be.
Thanks very much. And I'd love to hear the opinion of, Marion and Sven on this. So are you supported by venture capital, and also other funding? What are the challenges you faced? And, also what opportunities do you see maybe for public-private partnerships and supporting you?
Yeah, so indeed this cooperation has been crucial for the development of Kairos. First, because we've been working from the beginning, and we still are, with a lot of different research institutions. And I think in that space where there's innovation coming every day, we really need to be in close contact with those that are leading the research on applications and on the technology that is behind it. So we've been working with labs that are experts in data analysis from Earth observation, but also labs that are specialists in environmental data, so that we could bring something that brings value and makes sense. So this has been crucial, and I think we've been very lucky to have this in place. The second thing is, indeed, we've been funded a lot by ESA and CNES, especially on methane, but also we are now also receiving help on our work on forest monitoring and carbon sequestration. And this has been, again, a huge accelerator. I think what we see as something, now this is maybe my personal opinion, but I think something that is less advanced on public-private cooperation is the public institutions being customers for that data. We've seen that it makes sense for regulators to get those kind of data. The methane example was one, but there's a lot of them. on ecosystem monitoring, on risks, on measuring the impact of regulations and taking actions. You have the scale, you have the granularity, you have the cost-effective aspect. There's a lot. And we are progressively working with more of those institutions. So the UN, Department of Energy in the US. Now, on a not completely other topic, we are working with firefighters in south of France for wildfire risks management. But it takes a lot of time. And I guess in the US, for example, they are more prone to developing those kind of relationships. And it really helps pushing the technology forward, because it's really good that you get a grant or funding for the early stages of your development, but then you really need to find your market, develop new use cases, discuss the front options, whatever. And I think it's an underestimated way from the public institutions of supporting the development of this market. And I would love to see more adoption on that side. Now, I feel like one of the big blockers there is that satellite data still sounds a bit frightening for people who are not experts. And if you also say AI and algorithms, then it becomes really challenging, and people feel like they will have to be super experts to understand the data and to be able to play with it. So there's still a lot of education to be done there. And I guess what you were saying before is a lot of the innovation we have to do, companies in that space, to accelerate that adoption is in the way we present the data, so that it feels easy to use. And in the end, indeed, knowing it's from geospatial sources doesn't matter that much. It's more like you get reassured by the source of the data, because you feel it's something that is measured and auditable and transparent, but you don't really care in the end, because what you care for is the data and the way it fits your workflow.
Thanks very much. And so Sven, from your side?
Yeah, so exactly. I think the first part of the question was exactly whether we've gotten venture capital funding. So yes, we've raised venture capital until now, and so this is working. I think it gets more difficult the bigger you become, right? So maybe the next round which we're going to raise will be harder to raise, especially in Europe or from within Europe. So definitely late stage capital. Availability in Europe is an issue, but I think that is not something new. I think that also, like, exactly, with anchor customer governments as anchor customers is something which would be amazing. Also, I think everyone has heard this most likely a couple of times already. But we've also gotten support from the European Commission via the ESA funding scheme, which was really great. We also gotten funding by the European Space Agency, which is amazing. Now a couple of times already for the technical development. So that was really, really great, and I'm very grateful. I think where ESA and also the European Commission can work a little bit on is making the application process not less demanding, that's not what I'm saying, but less complicated to understand in the first place. If there's a factory acceptance test for a software company with all the requirements of a factory acceptance test, you might wonder whether this really makes sense, and whether it is useful work and paper to be created by us and be read by the other side, or whether it's just like something which has been built up over decades of funding. So I think that this is something where the European Space Agency and generally public supporters can maybe think about like how they can make their own lives easier by making our lives easier. And again, I'm not asking you to just give us money and say do whatever you want to do with it. Just make it really like applicable to the reality of a startup. And maybe that's something where people within this room can do something. But generally, I think like for early stage companies within Europe, I think the funding landscape in space and in the energy sector is there. And I think this is really great. Looking back at 10 years now, I'm in the new space industry.
No, thanks, and thanks for the feedback. So feedback taken on board. So we have just 5 minutes left, so I'd love for each one of you just to give us, a key message to the audience and really your thoughts on energy resilience. What does the future hold? What needs to be done? So I leave it open to you.
I'll start. Yep. To me, my key message is you're in a period of great change, and with great change comes great opportunities. So, those of you with a small business now, this is a great time to actually look at how you can assist in that change and actually grow your business. So I'm going to end with a positive note. I think this is a great time to actually be working in space and energy.
And I do agree. And I would say that the same amount of effort that is put on developing brilliant technology should be put on understanding how customers use it. But not only at a technical level, but however, if your solution has features that are beneficial imagine you are working with a grid operator, and the way grid operators access capital may have some specifications by government, they get funding. So imagine that you have a solution that helps your client to obtain cheaper capital to fund their investment. Try to stress that feature and get an understanding so that is beneficial for us working with you. I'll give you a very clear example. At ELIA, the regulation in Belgium is that if we work on projects that protect the environment, we get cheaper access to capital. Use that. And when you pitch your solutions to TSOs, understand what is the regulatory environment, how is the cost per capital, and try to, let's say, stress those features in your solutions then, that make it easier for us to work with you. Another thing that you mentioned, solar space-based power. We have 50 hertz, and earlier in Belgium, we have a team of colleagues working in 50 hertz to assess the use of solar-based power. And the questions that arise are very simple questions. What is safety? What is interference with telecom services? But the major concern that I would say concern, but how is it going to be regulated? Because we are transport system operators. Who is going to transport power from space to the ground? And those concepts need to be addressed from the start, because if we go up there and think of this wonderful technology, we don't think of how to actually implement it. We might not be making the most effective use of our time. And that means that talk to who is in charge of transmitting electricity, coupling points, where should it be, offshore, onshore, and what are the safety considerations? What are the regulations applicable? I think that's very important.
Absolutely.
Not the ideas, but how to make them happen.
Absolutely.
I think I already gave my key message, but I think that, generally, I think like oftentimes at these panels also complain that Europe is missing this or that. I think we have in Europe everything which we need. We have the funding in large degrees or in large parts. We have the people, the talents, we have the markets, so we can build global champions from within.
Okay, can you hear me? No, it's not working.
Yeah.
I don't feel it's working. No.
I give you mine.
Thanks. Yes, that's better. I would say on energy resilience, there's one topic that is kind of well covered with data now. It's transition. So how are we making the energy sector less polluting, less emitting, less impactful in terms of emissions in particular? I think we have good data and transparency on this, and there's a lot of regulations that have been passed recently or are going to be passed in the coming years, and this is accelerating a lot. Now, when I think of resilience, I think that the biggest topic that is ahead is risk management, because it's also how the energy system is going to handle natural catastrophes, for example, and also dependency from natural resources. And that's something that is driving our efforts at Kairos as of today. We are working a lot on measuring the impact on the environment, the dependencies, in terms of land use, in terms of water consumption, and anticipating how our infrastructures are going to respond to increased climate hazards in the coming years. And this is, again, lots of innovation because you have to do climate scenarios, etc. But it's really crucial because if we just think about, okay, let's reduce our emissions, let's replace this power by this source, but we don't anticipate the fact that there will be no water in that area, or there will be those that crazy amount of days with heat waves each year in that specific area, then we won't be ready for what's coming next.
I'm a big believer in human ingenuity, and especially in entrepreneurial ingenuity. And as all us sitting here in our respective roles, we need to focus on removing the obstacles. And as Sven mentioned, this is just a couple of those obstacles, but removing all the obstacles, be that financial, regulatory, business, whatever obstacles there are, to make space for those like really genius, sometimes entrepreneurs, with dynamic ones, to come in and help us build in this world of massive tectonic changes. I agree with my co-panelists. It's a massive change. It's not only energy. Every area of the world is undergoing a massive tectonic change, including energy. And it's a time of opportunity, and I believe entrepreneurs are the ones to take the advantage of the opportunity. So let's work to remove the obstacles. Let's make them operate, and let's be proud of it. And I always cherish and I admire Americans, how they are able to encapture or encapsulate in a simple terms, like big messages. And what I love about America these days is somebody captures like American dynamism. It's got like various angles to that, but this encapsulates this tremendous energy within the entrepreneurial world in America to build America again, to be dynamic again. So I'm calling to for a European dynamism program where I also believe we have everything. Yeah, we need a perception change, and this European dynamism should encapsulate this perception change, this mindset change, and at the same time, all of us, we should start removing the obstacles for entrepreneurs to really deliver some amazing solutions.
Thank you very much. So big round of applause for our panel. Thank you very much.
Thank you very much to all of you. And now it's time for the concluding remarks. And I would like to call on stage Rita Rinaldo for those. Thank you very much.
Thank you. So, I will not take a lot of your time because I think we had a really good discussions in these couple of days. First of all, thanks to all of you for coming here. I hope you also enjoyed the working session as well as the dinner yesterday, the small tour. Myself, I've learned a lot about the topics because we heard so many different perspectives and we discussed, of course, energy resilience and sustainability. We learned also that there are synergies between the two topics, and we need also to take into account other elements of affordability, security. We talked about emissions. We talked about yesterday in the context of sustainability, all the different aspects related to circularity, new topics, new challenges related to urbanization, for instance, to the transit, to electric mobility. On our side, I think the message is that we would like to continue fostering this dialogue, first of all, this collaboration between different ecosystems, the energy ecosystem and the space, because we believe that we have shown that there are a lot of opportunities of using space as part of the wider digital solutions that could help the energy sector in all the challenges that we heard. So of course we encourage a further dialogue. We would like also to mention that we are always open to, of course, discuss with companies, with suppliers, how to support them in the development of their proposition and also in the expansion, in the scaling, in reaching out to wider markets and to the to more customers. And at the same time, we are open to the dialogue with the stakeholders operating in the non-space markets, in this case in the energy markets, mobility markets, to understand their needs and see how we together can develop initiatives that would help them getting the solution they really need and the business model adapted to their way of working. So feel free to reach us anytime, and we will be happy to continue this and to put in place new ideas and to help you developing your ideas. On a practical and logistic, let's say, communication, the presentations that were done this day, I know that there are questions, will be made available as long as, of course, the presenters agree to make them available. And with this, I think we can conclude. And of course, you're welcome to stay in Paris or have a safe return home. Thank you.